Good morning and welcome everyone. This is the FY 2025 University Programs Informational Webinar. We're going to start off with a welcome from Dr. Goff, Principal Deputy Assistant Secretary from the Office of Nuclear Energy.
Good morning, everyone. On behalf of the Office of Nuclear Energy, I'd like to welcome you to the fiscal year 2025 Nuclear Energy University Program Informational Webinar. I'm Mike Goff, Acting Assistant Secretary for the Office of Nuclear Energy. It's such a treat to join you virtually to discuss the importance of nuclear energy research at the nation's colleges and universities, our critical incubators of innovation. What an exciting time to be in the field of nuclear energy. It is clear that nuclear energy is going to continue to play an important role in our nation's clean energy portfolio. Here at the U.S. Department of Energy, we're working diligently to not only maintain the operating fleet of reactors, but also demonstrate and deploy advanced reactor technologies to help meet ambitious energy and climate goals by 2050. As many of you know, there are still numerous challenges that we need to overcome in the nuclear industry to achieve these goals, such as making the current fleet more economical, expanding market opportunities, getting past first-of-a-kind deployments, and shoring up our nuclear fuel cycle. But our future continues to be bright thanks to you. There are many brilliant and dedicated folks at colleges and universities, national laboratories, and throughout the industry who seek to help us overcome these challenges. That is why it is so important for the Department of Energy to provide necessary resources and funding to allow you to do what you do best: innovate, problem solve, and achieve technology breakthroughs, while at the same time recruiting and inspiring the next generation of leaders in nuclear energy R&D. We recognize that this is not easy work. That's why the Nuclear Energy University Program is here to help you succeed. Since the start of many of these programs, we've seen some of the most influential contributions to nuclear technology research of the 21st century, including advanced reactor concepts, accident tolerant fuels, and structural materials of nuclear reactors. Just last month, the Department of Energy eclipsed $1 billion in total funding to U.S. colleges and universities to advance nuclear energy research and development. I'm proud to share that this historic investment has supported critical work at 139 colleges and universities across the country, including DC and Puerto Rico. This includes 833 undergraduate scholarships and 435 graduate fellowships. At last count, more than 2,400 students have been supported by various awards. We're also making inroads when it comes to fostering diversity in nuclear energy research and related STEM fields. Over the past 3 years, we have awarded $25 million to minority-serving institutions, and we hope to see this number continue to climb through the ongoing outreach and engagement efforts. The team will walk you through the funding opportunities that will be available in the coming year that span from student support to research and development to infrastructure. Thank you for joining us today to learn more. These funding opportunities represent a critical investment, one that strengthens our energy security, which is national security, and at the same time moves our nation and the world closer to realizing a clean energy future. I look forward to seeing your continued success.
Okay, big thanks to Dr. Goff for that video. We're going to move on to some welcome and introductions by Aaron Gravel, our Acting Director of the Office of External Innovation, and Dr. John Gilligan, NEUP's Integration Office Director.
Well, good morning, everyone. Thanks to Dr. Goff. We appreciate his continued leadership and support to NE's university programs. And good morning and welcome to all of you. We do appreciate you joining us for the Office of Nuclear Energy's fiscal year 2025 Nuclear Energy University Programs informational webinar, where we will today review with you multiple FY 2025 funding opportunities, and in turn provide an opportunity for you to ask questions and receive feedback. My name is Aaron Gravel, and I'm the Acting Director for the Office of External Innovation, which is in the Office of Strategic Crosscuts, led by Deputy Assistant Secretary Alice Caponiti. To give you an idea of what programs are included in the Office of External Innovation, that portfolio includes, of course, university support, So all of the funding opportunities that we will discuss today, and also industry and external engagement support through programs that you are all familiar with, like GAIN, SBIR, STTR, and OTT's sponsored Technology Commercialization Fund program, and several others. Before we get to our FOA overviews, here in a few minutes, you'll have an opportunity to hear from NE's office directors who provide guidance and direction to the formulation of the work scopes and topic areas in the various university solicitations. They'll provide overviews of the work they are currently engaged in, their respective offices. And in the next couple of weeks, you will receive an invitation to sign up to participate in topic area discussions for the CINR R&D FOA. Program managers will be present to discuss the topic areas and be available for a Q&A session with you. And please look for that invitation, and I do encourage you to participate. Last year, at the request of many of you in the university community, our program schedule went through a rework where we escalated the release of our FOAs, which in turn sped up the entire process, leading to award announcements for 4 of our FOAs and the UNLP scholarship and fellowships on April 6th and April 12th, just last month. Again, this year, we have continued to work on the escalation of that schedule and are providing this webinar another 3 weeks earlier than last year, with the goal to announce awards earlier by about 1 month. Our target for award announcement for fiscal year 25 is the first week of March. And for scholarships and fellowships, the announcement will again be sometime around the first week of April. I do have a couple of slides to run through really quick. So CC, if you can go to slide 2. This just provides some of the dates that are part of that escalated schedule. So you can see that we have our CINR R&D, which is going to be released this month. Program manager Q&A sessions will be towards the end of the month, with our pre-applications due in June 26th, and pre-application invitations September 2024, with full applications due this year on November 13th. Again, our award announcements are planned for the first week of March. Again, for IRPs, you can see the FOA is, of course, that's all part of the CINR FOA. Those applications will be due March or November 13th. And again, award announcements the first week of March. And here's the specific dates for NSUF if you're planning to apply for those opportunities. The LOIs are due June 5th, with pre-application statement of work August 1st and full application statement of work October 17th. Next slide. You can see all of our FOAs that we'll discuss, of course, throughout the day, but our DECP, again, releasing next week. Applications are due August 6th, and again, award announcements in March. Our Phase 2 Continuation FOA will also be released next week. LOIs are due June 5th. Full application invitations will come out August, and we'll get more specific dates, of course, for you as that becomes more apparent. And then full applications will be due in October, with award announcements again in March. And just a reminder, our requests for information are open continuously. And this next year, we will be moving the submission deadline for FY26 input to January 2025. That allows us to have a little bit more time in this escalated schedule to incorporate your ideas and to get those in front of program managers for review. Next slide. Here's our scientific infrastructure support. So we call it for short CINR infrastructure. This is our reactor upgrades and general scientific infrastructure FOA. We'll release that FOA next week, with applications due middle of the summer here, July 17th, and award announcements in March. Our reactor sharing and outreach FOA, we'll be talking about that briefly today. And we'll have more information as we get a little closer to this one. But this FOA will be released in August, with applications due October 16th and award announcements in May. as well as the infrastructure revitalization. Again, this is the second year for this FOA, and that will be released in November. So a little bit different. Last year, we released both reactor sharing and infrastructure revitalization at the same time, which ended up being around the first week of December. And we've split those up at the request of many of you to give everybody a little bit more time to focus on these FOAs separately. So hopefully that helps everybody out this year. For infrastructure revitalization, applications are due February 12th, and award announcements will also be in May. And next slide. And then, of course, our scholarship and fellowship, which is under the University Nuclear Leadership Program. Those RFAs will be released in August. Applications will be due in January, with award announcements in the first week of April, as well as our Innovations in Nuclear Energy R&D student competition. That RFA will be released in October, with applications due in December, and award announcements also that first week of April. Most importantly, what I would ask and remind you is take a look at the funding opportunities when they're released. All of the ones that you're interested in, all of these dates will be listed on the cover page of those FOAs. Now, on behalf of the federal staff and the Office of External Innovation, we want to thank each of you for your support, helping to make NEUP the program it is today. Running successfully since 2009, this year marks the start of the program's 16th year. We're also very excited to announce to you, and you just heard from Dr. Goff that with this year's announcements, the 24 announcements we had last month, NE surpassed the $1 billion mark in funding to universities, and that's really exciting. We're looking forward to another billion, hopefully over the next 15 years. And with that, I also want to thank the team of folks that play a very important role in providing support to the Nuclear Energy University program. This team is led by Dr. John Gilligan, who's the director, and by Drew Thomas, who is the manager of the INL Integration Office. Together, they lead a talented team that works to support the FOAs and RFAs that will be discussed today. And throughout today, you'll have an opportunity to hear from many of the federal staff that are in the Office of External Innovation that work in the university support programs, as well as the INL staff that work within the program as well. So we're very excited about today, and we hope that you enjoy the webinar. And I'd like to now turn the time over to Dr. John Gilligan for his introductory remarks, and then we'll get started. Thank you all for being here, and John, the floor is yours. Thank you.
Okay. Thank you very much, Aaron. I appreciate it very much. And we want to thank DOE, of course, for your support of the program, as you mentioned, over these many years, since 2009. It's the lifeblood of the growth and nurturing of programs at universities throughout the U.S. and for graduate students, undergraduate students, faculty, and staff, et cetera. So thank you very, very much. We're very appreciative of your leadership, Aaron, and that of Alice, as you mentioned, Capinetti, who've been involved with the program very strongly over the last number of years, and also really anticipating and thankful to have Mike Goff on board. Dr. Mike Goff has been involved with the program over the years through INL and and through DOE, of course. And so we have a lot of confidence that he's going to provide great leadership here as time goes on, especially for the universities. I did want to mention, as Aaron did, the strong support that we have at INL, where the staff of NEUP reside for the most part. Drew Thomas, our lead manager there, and the great team that we have supporting the program, who are the people actually you'll be talking to on a day-to-day basis in regards to questions and so forth. So thank you very much. Get to know our team and also the folks at DOE and the manager type positions as well as we go through the program today. Last year for 2024 was a real bumper year for us in the university programs. by the time everything is announced here, we've still got a couple awards to be announced in the next couple of weeks. But by the time that's done, we'll be close to $80 million in awards for 2024, which is probably, as far as I can remember, the biggest year that we've ever had in terms of support dollars total, and also number of kind of awards that we've and programs that we've awarded in. You'll recall last year we had new programs. The phase 2 continuation started up, and that's continuing again here. The revitalization infrastructure started last year. That's continuing. The reactor sharing program started last year. That's continuing. REUs supported in the CINR. That's continuing. The paper competition national paper competition started 2 years ago, I believe. That's continuing. Lots of new programs to present to universities this year, you'll see. Nothing new beyond that. So we're still trying to catch our breath in terms of all the new programs and support that we are providing. We will have a few nuanced kind of wrinkles coming up. The work scopes that you've been introduced to already are also broad this year, not too much change. And so I think that's a good thing. We're going to improve our review process to accommodate those broad work scopes. We're always working on that. And as Aaron mentioned, there's new titles at DOE to help support the university programs. So the new Office of External Innovation is really kind of designed around the university programs in a lot of ways. So we're very appreciative of that. It shows the high profile that NEUP and our associated programs have at DOE. So I think you're going to be impressed with the 2025 offerings that we have. And Aaron also mentioned we're trying to move the dates up so that awards, for the most part, are going to be announced in the beginning of March, about a month earlier than previously, which was several months earlier than the previous year before that, in order to allow faculty to know about their awards early so they can recruit graduate students, basically, and also get the fellowship and scholarship announcements out there as soon as possible as well. So we're looking forward. You'll notice in the schedule that Aaron presented, there are earlier dates for pre-applications and so forth. That's required in order to get everything done so that we can have those announcements by early March or March 1st. So it's an exciting time. We're trying to meet the needs of the universities and the faculty and the department heads and the various constituencies that we have in all that we do, and we appreciate your feedback. Finally, I'd like to just mention and thank former Assistant Secretary Dr. Katie Huff at DOE for her strong support of the universities over the last 3 years that she's been effectively in that position. She's gone back to her faculty position at University of Illinois. And we really thank Katie for her strong support over those years and the incredible amount of energy she brought to the NEUP and all the university efforts that we've had. So if you do see Katie, make sure you thank her for everything that she did. Katie, thank you very much. And you've made a huge difference for the universities in this country in the time that you've been involved, among all the other things that you've been involved with, of course, at DOE. Thank you very much for attending. We should have as many as 300 people attending today, on and off, depending on your interests. So it's a huge amount of interest in the programs. We get a large number of proposals. Unfortunately, we can't fund all of them, but that's just the nature of the business that we do. So we appreciate your support in all that you're doing. So I'm going to turn it over now, I believe, back to CC, so you can take control of the program and we can start to talk about the mission overview.
Great. Thank you so much, Aaron and John. We appreciate everything that you guys do. We are going to move on to any mission overview slides. There will be a question and answer, time for questions and answers after all of these presentations are finished. We're going to go ahead and start off with NE41, Fuel Supply Technologies.
Hello, my name is, can you hear me?
We can hear you.
Okay, thank you. Good morning, everybody. My name is Frank Goldner. I work for Bill McCaughey. Next slide, please. You'll see NE41 is in the NE4 row on the chart of the programs that we have. And I'll be talking about 41 and the one below it, 42. 41 is a new program dealing with supply technologies. And although I don't see any immediate university participation directly, clearly when we have a new program, one never can tell. So this one is kind of for your information of how in the newly reorganized offices we have, it's an important area. Next slide, please. Basically, it deals with the important issue of how we increase the domestic supply of fuel for all these new reactors we're talking about, especially. And so that this is for your information, we're right now in the process of preparing to figure out how to get more industry involved in order to have more in the United States, because right now, as you know, a significant amount of uranium comes from Russia. And so for, I think, as very good reasons, we want to increase the capability here in the US. And that's one of the main missions of this NE41 activity. We're seeking industry things. By about June, we'll be putting out a more detailed, call for participation. Will, I think, have future possibilities, but right now it's just for your information of this area. Next slide, please. And one of the vehicles that we're doing to support this is, of course, to have an activity to use high energy, high assay, low enriched uranium for these future reactors that you'll be hearing about in many of the other presentations. And we have a program that's very active. As you can see, we already have stepped up a facility that is producing early new amounts of this HALEU. And in the long term, we're going to work with the private sector to have much more of this available. So again, this will be supporting what you will hear in other presentations. Next. So basically, I just wanted to give you an idea. As I said, this is a new area, and it's very important. And now I guess I can move on to the second area, if that's all right. Okay, this of course is the area for which I'm the federal program manager for the Accident Tolerant Fuel Program. So this is an area close to what I know about, and I'm looking forward to talking to you a little bit about it. Next slide, please. As you can see in the lower left there, NE42 is all still under John Carmack, NE4, and this is a mainstay of our advanced fuel, of our fuel development area. Actually, it's focused more on what we can do with the existing reactors, the existing fleet. This box really, it's what is the existing fleet, not everything, of course. And they're all upgrading their facilities to try to commercialize within this decade fuels with enhanced accident-tolerant characteristics. But in addition to the accident-tolerant characteristics, they also appear to be capable of enhancing the capabilities of the fuel for higher burnup tolerating higher enrichment to get the higher burnup, and so it's a very exciting program. Next slide, please. So this is the program for which I'm the federal project manager. We have 3 parties that are working with us right now, of the largest producers of fuel, I would say, in the world: Westinghouse, General Electric, and Framatome. And we're trying to enhance concepts with significantly enhanced tolerance for accidents. As you can imagine, this program was stood up after the Fukushima incident about 12 years ago or so, and the companies were very eager to develop advanced fuels. And within a year or so of the standing up of the program in about 2012, a year after the accident, and these are the type of concepts that were proposed. Doping fuel, that's where you put in some additives like chrome bearing or aluminum bearing or others. Obviously, in Fukushima, the creation of hydrogen was one of the greatest contributed to the accident in the reactors. And so obviously, we're all looking into coated cladding of what they're doing. And it turned out that when we do the doping and we do the coating clad to enhance the accident tolerance, the companies right away realized that these 2 features permit the fuel to perhaps perform better, longer, etc. And that also helps in the viability of the concept, because if they can make more money, obviously it helps. So we're talking now about high enrichment. We use the term LEU+, which is like anything from the current 5% up to a little less than 10%. It's included in the group that earlier I talked about called HALEU, but usually HALEU is, as other reactors are considering it, the smaller ones are greater than 10%, but it's actually obviously a potential user of HALEU. And so that there's an enrichment thing. And very important is also getting to higher burnups. The current fleet is licensed to about 62 gigawatt days per metric ton peak burnup. And there's a great incentive that with the characteristics that we have in our enhanced fuels for accident tolerance, as well as capabilities with LEU+, to go up to 75,000 burnup. And that, of course, is of great interest to the vendors and the utilities, of course. So we do provide funding, a significant amount of funding every year. I think the program, the total accident tolerant fuel line item is in the 90 to 100 million item, which covers many things more than just this. We also have a great involvement with our national laboratories. I cannot underestimate how useful it is to have the excellent national lab system, specifically at these labs, but there are more involved: Idaho, Oak Ridge, Los Alamos, and Pacific Northwest labs. There's also Brookhaven that supports us, and we have other interactions with other labs. But as part of the accident tolerant fuel program, one of the wonderful things we've done is enhance the lab capabilities. And I think there's a spin-off from what we're doing in this program, also to support the small reactors. Next slide, please. And I mentioned accidental fuels. In the future, we are planning to have there'll be a new line item. I think it starts with the fiscal year 25 situation, where clearly we have capabilities that we've been developing under accident tolerant fuels, which also have value to future reactors. So we'll be standing up a new line item activity, still in this 42 box that Bill McCarthy is the director of. And we're going to see what we can do to derive innovation. And in the nearer long term, when this starts, that's what the second bullet is to indicate. We'll be looking for concepts some of them which we have considered early on in the accident tolerant fuel program, but they have longer term time periods to bring them vendors. And in the near term, the question is, what can we do to other advanced fuels of importance? Clearly, you'll hear in other presentations about metallic fuel, molten salt fuels, TRISO, which is silicon carbide related fuels that there's been a lot of development, but we think that there's a real impetus of our office expanding, and this is the vehicle. And again, we'll use our capabilities of the excellent lab teams that we have set up, to help us with in proving out new ideas in design. We have a strong post-irradiation examination capability at several of the sites, and that's something where you can support in an area that it's very difficult to fund when you're starting up something new. And another program in DOE that's in one of the, again, you'll hear from, is modeling and simulation. I think I've seen in the last 20 years or more develop tremendous capabilities in our civilian programs to support modeling and simulation. And I think it's one of our vehicles to lower the time for commercializing a new fuel from what historically has been almost like 20 years to hopefully 10 years or less. So again, we're looking forward to support new ideas and all. Next slide, please. That may be it. So I've covered two areas in my time allotted. And obviously, you'll see the call, or you have seen the call for 25, and there'll be a webinar where we can discuss further these topics. But we believe working with the universities and the national labs is extremely useful for new ideas. I think we're in some kind of an exciting time where a lot of new ideas are coming through. It almost reminds me of many, many years ago when I joined the DOE and its forerunners. And I think we're in a very, as I say, new period where new concepts have a real chance, driven by this 2050 goal that you heard about. That's kind of almost to me like a wartime setting where we have to make something occur as soon as possible. So I look forward to learning more about the other systems also. Thank you for your time.
Thanks so much, Frank. We appreciate that. We're going to move on with NE43, Materials and Chemical Technologies.
Good morning, my name is Stephen Cohn. I will provide an overview of the Office of Material and Chemical Technologies and NEUP topical funded under NE43 office. Go back to the slide, I haven't finished that one. So before moving into the presentation, I want to mention that the mission of NE43 is the office is to maintain and expand the technical capability in chemistry and the material science for a broader range of nuclear engineering applications. So we are a group of diverse people here trying to support the nuclear energy technology development. And my contact information is here. So next slide, please. So this slide just basically shows NE43 program managers and their program responsibilities related to FY25 NEAC topic highlighted in yellow areas. So for example, we have Dr. Bill DeCool. He manages aqueous separation and vapor phase separation. Ms. Kimberly Gray, she manages off-gas and advanced wasteform. And Sue Lazica, she helped all the material coordination, and specifically for the NEAC call, she will manage art and the light water sustainability program material R&D areas. And Tansel Selekler will manage material protection, accounting, and the control technology. We call the MPAC. And also for the Dr. Ming Tan, so he manages innovative nuclear materials. And Dr. Jim Willett, he manages pyroprocessing, molten salt chemistry, and the new area called the molten salt fuel. Next slide, please. Yeah, the first technical areas within NE43 program responsibility is material recovery and waste form development. We call MRWFD. So the mission for this material recovery waste form development is to develop advanced fuel cycle technologies. So we seek to address long-term sustainability of nuclear energy by improving resource utilization. We reduce the quantity of high-level waste by to alleviate the repository burden. So we want to limit proliferation risk by enhancing safeguard and securities. And lastly, we want to improve the economics by reducing technology cost. So how to reduce technology costs? We seek at least two areas. One is to recycle all nuclear fuel materials, not just actinide. And the second one is we try to simplify the technical and the physical chemical and the physical processes. So to reduce the complexity of the technology. So in that case, we can reduce technology cost. So within this campaign areas, we have 5 areas listed below. One is advanced aqueous processing and vapor phase separation. That's under Dr. Bill DeCool, I mentioned earlier from previous slide. And the pyroprocessing and the molten salt separation is managed by Jim Willett, and off-gas capture and the advanced waste form is managed by Ms. Kimberly Gray. Next slide, please. The second area for NE43 program responsibility is MPAC, material protection, accounting, and control technologies. So the mission for MPAC is to develop innovative real-time or near real-time technology, which include tools, sensors, and methods to support the fuel cycle technology developers for them to effectively and economically address nuclear material control and accounting requirement. So please note that the development technology focuses on U.S. domestic applications. So the international safeguard security is managed by our colleague within NSA. So we focus on domestic. So we develop a safeguard performance model for both front and the back end. And we incorporate safeguard by design concept early in R&D process. And we develop sensors for real-time measurement. And we advance electronics for non-destructive assay, NDA. So that's kind of an example technology focus area under MPAC. Next slide, please. The third area is relatively new, called the innovative nuclear material. So in this area, we develop next generation fuel cladding and the in-core materials. And also we address nuclear material recycling and the reuse issues. So within the technical focus areas, we focus on cladding materials. So for material design, material performance, and material fabrication and the manufacturing technologies. So that's the third technology. Next slide, please. So in this slide, we highlight all the technical topical areas under NE43 responsibilities. The first one is topical area 3. You will find in the solicitation. So it's called the nuclear fuel recycle technology and managed by Bill DeCool and Jim Willett. So we developed advanced recycling technology, as I mentioned, and also we want to address fundamental material separation and recovery challenges. So I think this fundamental separation science is our focus for university, because for university folks, you may not have the hot cells. And then if you do the fundamental science, it's much easier for you to do this. And then the next area is topical area 4 under fuels, specifically under molten salt fuels. Jim Willett will manage that. So if you are interested in this topic, please referring to the workshops we conducted last year under MSR fuel cycle chemistry R&D needs at Argonne. So it's published in the website listed in here. So you can also find in the solicitation, they are listed over there. So there are potential interest areas you can find in this workshop. We use the workshop to guide our program plan. So the next area is topical area 10 for licensing, safety, and security. Under this one, our material MPAC program, innovative material material control and accounting methods and tools for fuel cycle. In this case, we focus on the front end and back end. We don't focus on the reactor. Reactor is managed by NE5. So tensile selector is the program manager. So next area is topical area 11. So it's advanced nuclear materials. So we, as I mentioned earlier, we focus on cladding material only. So in this case, Min10 is our program manager. And another area under advanced nuclear material is innovative material for off-gas capture and wasteform. Ms. Kimberly Gray is managing that. If you have other material or chemistry areas, you have great ideas you want to submit, you are always welcome to submit under topical area 12, blue sky. For nuclear material and chemistry topic, we are not soliciting in our current topical areas. Thank you for your interest in NE43 program. I think that's all I have for this presentation.
Thank you so much, Stephen. We're going to move on to NE51, reactor sustainability.
Good morning, everyone. My name is Janelle Eddins, and I am the Acting Director for the Office of Advanced Reactors. Today, I'm going to be covering both the NE51 and the NE52 offices. Next slide, please. Okay, so first up, we have NE51, which is the Office of Reactor Sustainability. And there are 3 main programs within this office, which I will cover in the next few slides. Next slide, please. The LWRS program is working to enable long-term operation of the existing fleet and deploy innovative approaches to improve economics of LWRs. We do this through a combination of directly funded lab R&D, cost-shared public-private partnership with industry, work with universities and small businesses, and finally through interactions with various stakeholders, including NRC, EPRI, and NEI. And the LWRS program is broken down into 5 focus areas or pathways. First, we have the plant modernization pathway, which supports research to enable modernization of plant systems and processes across the industry by enabling a shift from labor-centric to technology-centric business models that support improved performance at a lower cost. The next pathway supports research to establish the technical feasibility and economic potential of dispatching thermal and electrical energy to diversify and increase revenue. The third pathway supports research to enable decision-making related to the economics, reliability, and safety of the existing fleet by providing analytical solutions for integrated plant systems. The next pathway, the materials pathway, supports research to develop the scientific basis for understanding and predicting long-term environmental degradation behavior of materials in nuclear power plants. And then finally, the physical security pathway supports research that will validate methods and tools which can be used to implement an updated and cost-effective physical security regime. Next slide, please. Okay, so the ARSS program is addressing near-term challenges that advanced reactor vendors will face in meeting domestic material control and accounting, physical protection system, and cybersecurity requirements for reactors built in the US. And as you can see from the diagram, within each of these program areas, research is performed at the systems level. And some of this research includes MCNA approaches for pebble bed and molten salt reactors, physical protection system approaches for SMRs and microreactors, and cyber-informed engineering and defensive cybersecurity architecture approaches. And research is also being performed at the technology level, including, again, MCNA techniques and delayed technologies and response techniques for physical protection systems, and secure elements and supply chain research for cybersecurity. Next slide, please. Okay, so while the current landscape for nuclear energy in the US is our large plants providing reliable baseload power, the future landscape is expected to look quite different. So we expect to see a combination of existing and advanced nuclear plants not only producing electricity, but also working to decarbonize the transportation and industrial sectors of the economy by delivering chemical and thermal energy to industrial processes for making fuels and products. And the IES program is organized into 4 pillars. The first pillar is focused on estimating the U.S. market potential for developing nuclear energy to produce hydrogen fuels, electricity, and thermal heating. The next pillar will accelerate the time frame to market for the clean energy that can be provided by advanced nuclear reactors. The third pillar designs thermal and electrical power dispatch from advanced nuclear reactors. And finally, the chemical conversion pillar aims to tackle the industrial emission issues by powering production with near zero carbon nuclear energy via innovative production processes. Next slide, please. I think we could go ahead and skip this one. Okay, so now we're moving on to NE52, which is the Office of Advanced Reactors. And there are 2 main programs within this office with a number of sub-programs, which I will cover on subsequent slides. Next slide, please. Okay, so first up, we have the ART program, which is working to develop and commercialize innovative non-light water reactor concepts. And we do that by working with a number of key stakeholders, such as national labs, universities, industry, other federal agencies, as well as international entities. And within the ART program, there are 5 focus areas. First, we have the MSR campaign, which looks at 2 variants of the MSR. One has the fuel dissolved in the molten salt coolant, and the other variant uses solid trisul fuel. And in that campaign, we focus on investigating fundamental salt properties, materials, models, and fuels to support these reactors. Next, we have the FAST reactor campaign, which is focused on development of technologies that use liquid metal coolants and operate in the fast spectrum. And that program looks at de-risking and demonstrating fast reactor components and technologies, providing validated codes and experimental databases, and qualifying advanced structural materials. Then the gas reactor campaign supports development of high temperature gas reactors. And these reactors use helium as a coolant and operate at very high temperatures in the 750 C range. And this campaign is focused on alloy qualification and scaled experiments to support design and licensing. We also support a graphite qualification program where we irradiate, examine, and qualify nuclear grades of graphite for use in high temperature reactors. And then finally, the ART program supports development of microreactors. And microreactors are a cross-cutting category of very small reactors being designed for non-traditional markets. And in the ART program, we support both nuclear and non-nuclear testing for micros. Next slide, please. Okay, so moving on to Advanced Reactor Regulatory Development Program. The Office of Nuclear Energy coordinates very closely with the NRC and with industry to address and resolve key framework issues that directly impact advanced reactor deployment. And a key part of that program has been working with industry to help develop a regulatory framework for advanced reactors. And these activities are based on establishing a risk-informed and performance-based approach for advanced reactors. And this is necessary because the current regulations are really set up to license these large light water reactors. So we need to modernize the framework to be more applicable to advanced reactors that use different coolants. And within that program, we also support targeted research to reduce technical and regulatory risk by providing the bases for establishing licensing technical requirements. So some things we look at in this area is ASME code qualification of alloy 709, looking at radionuclide transport, and also scaled experiments to support licensing. Next slide, please. National Reactor Innovation Center, or NRIC, is led by INL and is providing a range of capabilities to support nuclear technology demonstrations. And one thing that NRIC is doing is establishing demonstration test beds. And these test beds will provide the infrastructure where developers can come in and test their technologies and get the data they need to support design and licensing. And the first of these test beds is the DOME test bed, which will support microreactor technologies. And we expect this test bed to be ready for the first test as soon as 2026. We're also working on a second test bed, which can support experiments that use high security materials for operation. And NERC is also working on advanced construction technologies. They're working with industry to develop these construction technologies that could significantly reduce the cost and decrease the timeline for nuclear construction. Next slide, please. So I just wanted to give an example of some of the advanced reactor experimental capabilities that could be appropriate for use with NEUP projects. It's not meant to be an all-exclusive list, but just a few examples. So starting from the top left, we have METAL, which is a liquid sodium test loop that's at Argonne National Lab with about 3,000 kilograms of reactor-grade sodium. And we've used METAL for many NEUP projects, most of which focus on developing sensors and instrumentation that can then be tested in METAL. Then we have this SPHERE facility, which supports microreactors. And to give you a perspective on what types of tests can be done in SPHERE, we do plan to determine thermal conductivity in a gap-through-gap conductance testing. And we're also planning to test components made with additive manufacturing. We also have a couple of molten salt test loops at Oak Ridge. And the FASTA loop that's pictured here is a chloride salt loop. There's also a fluoride salt loop, but it's not currently operational, but should be back in operation pretty soon. And these loops can be used to support a variety of testing, including chemistry and corrosion control and sensor testing. Then at the bottom left, we have the magnet facility at INL, which is a non-nuclear test bed for performance evaluation of microreactor design concepts. And magnet uses electrical heating elements to simulate core thermal behavior, primary heat exchanger performance, and passive decay heat removal for heat pipe and gas-cooled microreactors. And some examples of how magnet can be used include looking at heat transfer within microreactor components, looking at structural performance of core structures, and supporting power conversion studies and evaluation of heat pipe performance. And both magnet and SPHERE can be used as a test bed for low technical maturity instrumentation. Then moving to the right, we have Marvel. And Marvel is going to be a microreactor that's planned to be built at INL to serve as a nuclear test platform to demonstrate microreactor operations and end-use applications. And although Marvel won't be operational until 2027 at the earliest, we did want to leave the window open to those who may propose activities related to design sensitivity studies or studies on unique INC interfaces. We're also interested in microreactor automated control systems, or MACs, which can also be demonstrated with the Marvel technology. Then finally, we have the VTB, which serves as a repository for reactor models. And an example of an activity that could be funded through CNR would be leveraging the existing simulation models or developing new models to be hosted on VTB. Next slide, please. Okay, so in addition to our lab research and capability support, we also support cost-shared partnerships with industry. So the next 3 slides show 10 projects that are supported through our ARDP and our ARC-20 programs. I'm not going to walk through those slides, but I did want to include them as examples of the vendors that we're working with and the types of reactors that we're looking at. So although it's not required, if you wanted to partner with any of these companies, just wanted you to have some examples. And of course, this list is not all inclusive. There are other reactor vendors that we're working with as well. And I think those were my last slides. Looking forward to questions at the end of the session. Thank you.
Thanks so much, Chanel. We're going to go ahead and move on to NE72 cross-cutting capabilities.
Okay, good morning, everybody. I guess while we wait for the slides, I'll just introduce myself. My name is Sibel Schaffner. I am the director for the Office of Cross-Cutting Capabilities and 72 under NE7 Deputy Assistant Secretary for Strategic Crosscuts, Alice Capomiri. Here we go. Thank you. We can go to the next slide. Okay. My office is responsible for the cross-cutting research, development, and capabilities to advance innovative nuclear energy technologies for existing reactor fleet, advanced reactors, and fuel cycle systems. So here's a list of my programs organized by R&D and capabilities, and I will provide a brief overview of each program coming up slides, highlighting some of the activities that are being conducted under each. Next slide, please. So this slide shows my team of federal managers and the programs that they manage. Dave Henderson manages the Nuclear Energy Advanced Modeling Simulation, NEMS program. Terrence Gallimore manages the Advanced Materials and Manufacturing Technologies, AMMP. Daniel Nichols manages the Advanced Sensor Instrumentation program. Chris Barr manages the Nuclear Science User Facilities program, NSUF. And Andrew Bollinger manages the University Fuel Services, UFS. Next slide, please. So starting with the NEMS program, it develops and deploys a set of predictive modeling and simulation tools to support and in some cases enable improved operation of the current fleet and the development and deployment of advanced reactors. NEMS supports the highest priority modeling and simulation capabilities to meet industry and Nuclear Regulatory Commission need to speed commercial deployment of advanced reactors. NEMS is a multi-lab effort that aims to develop and deploy predictive computer methods for the analysis and design of LWRS and non-LWRS. It is important to highlight that the NEMS tools are for others to use. Therefore, close coordination with industry and any R&D programs is vital. The graph here shows all the NEMS codes that are being developed to support multi-scale fuel performance and structural materials degradation modeling, reactor physics, multi-scale thermofluids, multi-physics, and workflow management. NEMS work is informed by experimental capabilities and data to best support reactor deployment and operation. So in summary, NEMS goal is for stakeholders to use these codes to support their needs. Next slide, please. So for AMMP, it's providing an integrated approach to support the development of advanced materials, advanced manufacturing methods, and environmental effect studies in support of nuclear reactor technologies. AMMP research is organized under the 3 areas listed on the left. Development, qualification, demonstration to focus on the development and qualification of advanced materials and manufacturing technologies for nuclear reactor environments in an expedient and efficient manner focused on demonstration. Second one, capability development and transformative research to focus on capabilities needed to support the materials development through improved techniques and technologies such as modeling and simulation, machine learning, and artificial intelligence. And the last one, collaborative research and development to focus the research to support the nuclear energy community needs with a broad set of options. In summary, AMMP research aligns material design, modeling, simulation, manufacture, and R&D efforts towards focused, goal-driven process and products whose end users can be adapted to the market conditions. This will accomplish through implementation of domestic, economical, viable technologies developed in coordination with the stakeholders. Next slide, please. The advanced sensor instrumentation is developing advanced sensors, instrumentation, and controls for monitoring and controlling existing and advanced reactors. ASI focused on the development, testing, and commercialization of reliable, cost-effective, real-time, accurate, and high-resolution measurement of the performance of existing and advanced reactor core and plant systems. So the research, as you can see from the graph, is organized in 5 areas. The first one is communications, focuses on resilient and real-time transmission of data to support monitoring and analytics. The second one, big data, machine learning, and artificial intelligence, focuses on technology for semi-autonomous operation and maintenance by design. Third one, advanced control systems, focus on increasing plant performance through near real-time controls. Next one is material science, focus on innovative sensors, materials, and manufacturing for harsh environments. And the last area, sensor performance modeling, supports predictive capabilities and integration in digital twins. In summary, the ASI program focuses primarily on activities to improve the performance of sensor instrumentation. For example, durability, reliability, harsh environment tolerance, enabling its wide adoption for future applications in nuclear reactors and fuel cycle development. Next slide. So the Nuclear Science User Facilities provides universities, industry, and national laboratories access at no cost to the researcher to world-class nuclear research facilities, technical expertise from experienced scientists and engineers, and assistance with experiment design, assembly, safety analysis, and examination to characterize the behavior of fuels and materials in a nuclear reactor environment. NSUF offers access to neutron, ion, and gamma radiations, hot cells and shielded cells, low-activity laboratories, beamlines, and high-performance computing at our partner, we have 21 now, partner institutions. Every year, NSUF competitively solicits and award facility access through this CINR funding opportunity announcement and also through the rapid turnaround experiment. So you will get to hear more details on the NSUF program later this afternoon. Next slide, please. Okay, so the University Fuel Services provides fresh fuel to 25 U.S. university research reactors located at 24 universities and removes their spent and damaged fuel as needed. The program supports the education and training of the future nuclear engineers and scientists, supports research and development for current and advanced reactors, and also supports some domestic isotope production. For clarity, listed under the last bullet are activities that our program does not currently support. We don't support new types of fuel development for NRC review and approval for advanced reactors. We don't support reactor operating equipment such as consoles. Those kinds of upgrades are usually performed privately through a university or through other competitive funding grant opportunities. UFS does not provide enriched uranium directly to universities. That is performed through other mechanisms outside this program. And finally, UFS does not provide universities with components related to fuel fabrication or assembly. To summarize again, the University Fuel Service Program is primarily a procurement program of commercially available research reactor fuel, and we dispose of the fuel after the universities are done with it. Next slide, please. So this concludes my presentation. I added a link to all the slides for more program information, and I thank you for your attention.
Thanks so much, Subel. We're going to move on to NE81, disposal research.
Hey, good morning. This is John Orchard. I'm making a presentation for NE81. We recently reorganized our NE8, and NE81 had disposal research and storage and transportation R&D. We moved storage and transportation R&D into NE82, and NE82 split off consent-based siting into NE83. And they'll be making their presentations after me. I'm making mine on NE81, which is disposal, research, and development, which is topic area 5 in the FOA. Proceed. Next slide. Okay, the grand challenge for the spent fuel and high-level waste disposition campaign is to provide a sound technical basis for the safety and security of long-term storage, transportation, and disposal of spent nuclear fuel and high-level radioactive waste from the nuclear energy enterprise. Next slide. Our mission, NE81, the Office of Spent Fuel and High-Level Waste Disposition, includes identifying alternatives for the disposal pathway, to provide a sound technical basis for the repository, to develop new technologies, models, and validation techniques, to identify and research generic sources of uncertainty, and to increase confidence in the disposal pathways. Next slide, please. We do this through a generic geologic disposal, GDSA, a generic geologic disposal safety assessment, which includes the following steps. We have a source, which is the waste package. There's the engineered barrier system, which includes backfills of bentonite and other materials that we're developing. We're evaluating the natural barrier systems, which includes the host rock, such as granite, crystalline granite, clay or shale, which is argillite, or salt. And from there we go on to the GDSA and look at the effects in the biosphere. Next slide, please. The three main host rocks we're looking at for a generic disposal is the crystalline, the argillite, and the salt. Next slide, please. And this is a depiction of what the waste package, the waste source, the waste package, the engineered barrier system would look like in a reference case for a repository. Next slide, please. Current areas of research in our disposal R&D is argillite disposal, which includes elucidation of the coupled thermal, hydrologic, mechanical, and chemical THMC processes that are affecting repository performance, and development of multi-fidelity approaches for integration of process models into the GDSA framework. We have we're looking at crystalline disposal, which is looking at the flow and transport in fractures, including matrix diffusion, and improved representation of the coupled THMC processes affecting fracture transmissivity. In the salt disposal scenario, we're looking at effects of the heat-generated waste on system behavior and evolution of the engineered barriers in salt. For the engineered barrier systems, we're looking at the analysis of thermal, mechanical, chemical processes affecting the EBS designs and materials for each of the host media, and also understanding bentonite buffer drying and resaturation processes. We're looking at direct disposal of dual-purpose canisters, which includes probabilistic post-closure criticality consequence analyses. And we're also looking at injectable fillers into the DPCs. In the geologic disposal safety assessment, we're looking at advanced simulation capability for repository system analysis, uncertainty and sensitivity analysis. For the inventory and waste form characteristics and performance. We're looking at interface with the online waste library, inventory of data for the GDSA. And we're looking to perform gap analysis and prioritization for the SNF strategic testing definition. For technical support for the underground research laboratories, we're looking at operational support for international URLs, and we're looking at testing and planning for passive unsaturated system gas flow monitoring and using cosmic muon radiation for studies. International collaboration on disposal research, we're looking at participation within the international R&D network in underground research laboratories for a range of geologic host rock systems and engineering barriers. And we're pursuing a more active role in conducting experiments and work in international underground research technologies. And then in knowledge management, we're looking to continue maintenance and development of the knowledge management repository and expand topical coverage and more fully for disposal programs. And also to develop internal training courses and expand the knowledge management repository efficacy to more of the nuclear energy fuel cycle community. Next slide, please. So this year we have 3 topics in topic area 5. First is improving the THMC modeling through improved interfaces between various model scales, improving geologic characterization through field tests, and improving performance assessment models through improved uncertainty quantification. And this is all explained quite a bit more deeply in the FOA. And that's the conclusion of my presentation.
We're going to go ahead and move on to NE82, storage and transportation.
All right, can you see my slides?
Yep, they look great.
Okay. Hi, everyone. I'm Erica Bickford. I'm the director of what is now the Office of Storage and Transportation, and formerly the Office of Integrated Waste Management. But as John Orchard just mentioned, we had a reorganization last month. And so our current office organization doesn't align with the FY25 NEUP scope right now, but we'll try and explain how that's working for you. So again, we reorganized, and what was the former Office of Integrated Waste Management is now organized into 2 offices. My office is the Office of Storage and Transportation, and then we have added an Office of Consent-Based Siting. And Marla Morales is the acting director of that office, and she's going to present on the consent-based siting office next. My office, Storage and Transportation, also known as NE82, includes NEUP FY25 topic areas 6 and 7, with 7 overlapping with the consent-based siting work. Our general program mission is to implement a federal interim storage capability for commercial spent nuclear fuel following a consent-based siting process. So we're a little different from the other NE offices, where we're more focused on constructing a facility and not as much on R&D. Our current program priorities for the next couple of years are as follows. First and foremost is our consent-based siting process that is intended to find willing and informed host communities to host federal facilities for storage and hopefully eventually disposal of spent nuclear fuel. And Marla will talk more about that next. And then in my office, we are working on designing and eventually licensing and constructing a federal consolidated interim storage facility, and also preparing to transport spent nuclear fuel to that facility. On our project progress for the federal consolidated interim storage facility, I'm pleased to say that we've made a major milestone just this week. On Monday, we received approval by Deputy Secretary David Turk of Mission Need to pursue a federal consolidated interim storage facility project. So we've been working on design work, going through independent reviews, mission validation, cost and schedule analysis. And here on the screen, you can see a graphic of our reference concept design for the facility. And here I have some more artist renderings from an earlier version of a reference concept design. We've actually made some revisions where the user-controlled area is expected to be smaller than as depicted in this graphic and closer to the operations area footprint. And just a couple more artist renderings. This would be the reference concept design currently is what we call cask on a pad. So this would take as loaded spent nuclear fuel from storage pads at nuclear power plants, focusing first on the shutdown sites. We have 20 shutdown nuclear power plant sites, moving it to this facility. The initial design would be 15,000 metric tons, and we would plan to then modularly expand the storage capability over time as needed, depending on when a disposal facility comes online. And we would have both vertical concrete storage systems, which is the system on the right in this image, as well as horizontal storage modules, which is the storage system on the left in this image. And then in the middle, you have a vertical cast transporter depicted. And here's just another kind of aerial view of the facility. That's our reference concept design. This isn't a final design. This is just the concept that we're working with as we move through this stage of the project. Additionally, in the reorganization, storage and transportation R&D activities are now moved into my office, the Office of Storage and Transportation. And so those are covered in the NEUP topic area 6. Some of the activities we're working on is a high burnup demo cask project. So that's where a cask of spent nuclear fuel has been loaded at a nuclear power plant containing high burnup fuel, and it has thermocouples through specialized modifications to the lid, monitoring the temperature to see whether the performance of high burnup spent nuclear fuel in storage and then eventually transportation is substantially similar or different to lower burnup spent nuclear fuel. This summer, we're doing some shaker table testing of spent nuclear fuel that simulates kind of earthquake situations and impacts, and going to be looking at simulated impacts to spent nuclear fuel in storage systems in earthquake conditions. We're collaborating with the Office of Environmental Management on a road readiness project at DOE Idaho, which is looking to package DOE-owned spent nuclear fuel at the site and load it into a storage configuration so that it can be ready to be transported off-site to eventual disposal facilities or possibly the Federal Interim Storage Facility if it decides to include DOE-owned material. And then we have some new work that we're going to be looking to do starting in 2025, really emphasizing more collaboration across the DOE complex with Office of Environmental Management and naval reactors, as well as with international partners who are, facing some of the same questions in terms of storage and transportation of spent nuclear fuel as we are. Related to that, we're entering into a memorandum of agreement with the Electric Power Research Institute, EPRI, to collaborate more with industry on research and demonstration of storage and transportation work. And as I mentioned, international collaboration initially focused on UK, Germany, Belgium, and Japan. And in this figure on the left, top left, you have a cask or a canister, for storing spent nuclear fuel with the basket inside, and this fuel assemblies go in each of those basket areas. On the bottom left is the shaker table testing facility at UC San Diego that we're going to be using this summer. Another activity we are preparing to conduct is shipping of that high burnup demo cask to a DOE facility. This R&D project started in 2014. Depicted in this image is the cask in a TN32B. Loaded at the North Anna Nuclear Power Plant in Virginia. You can see the instrumentation on it that's collecting that temperature data. This is a project that started in 2014 as a collaboration between DOE and EPRI. We are planning currently to ship this cask to a DOE facility for further monitoring and R&D, and we're planning to conduct that shipment in 2027. So we're doing lots of planning and coordination to get ready to ship that cask. To ship that cask, we are planning to use our Atlas rail car. For more than 10 years, we've been developing specialized rail cars to transport spent nuclear fuel and high-level waste. We have nearly completed the Atlas 12-axle rail car, which is depicted in the top left picture. That's expected to be approved for use in commercial transport either later this spring or early in the summer. It's going through the final review process. We collaborated with the U.S. Navy to develop a rail escort vehicle that's depicted here in the picture on the lower left. Security personnel will travel in that rail escort vehicle, and safety and security monitoring equipment for the rail cars will also be housed in that escort vehicle. Separately, we have designed and have started fabrication of a 8-axle rail car called Fortis. The reason we're pursuing 2 different rail cars is the as-loaded spent nuclear fuel at nuclear power plants in the US have been packaged into containers that will range from 80 to 210 tons when loaded for transport. And so we wanted to have a rail car that was more aptly designed for smaller, lighter weight packages, and a rail car that's more designed for larger, heavier weight packages. So to have the best equipment for the job at hand. We're also continuing development of what's called an Integrated Security and Safety Monitoring System, or ISSMS, for the rail cars. That will satisfy the rail car standards for providing near real-time monitoring of 11 different performance parameters on the rail cars. You may be familiar with the East Palestine rail derailments that happened last year. That I believe the preliminary assessment is that it was caused by an overheated roller bearing that was not detected early enough by a wayside detector that's on the railroad tracks. Well, our Atlas rail car and our Fortis rail cars will have onboard sensors that would detect an overheated roller bearing immediately and send a signal to the crew in the rail escort vehicle, notifying of the abnormality and indicating whether the rail car should be stopped immediately or at the next stopping point for inspection of that component. And there's 11 different components that are monitored on all of the rail cars. So these rail cars are specifically designed to prevent a derailment due to equipment failure. And then the ISSMS also provides tracking, a tracking capability, and that's something that we have integrated with DOE's Transcon system to provide to state government and tribal governments where these shipments will be transited so that they can monitor these shipments as they cross through their jurisdictions. Additionally, we are planning to conduct a package performance demonstration. The packages to transport spent nuclear fuel are Type B packages. Historically in the US, there was some physical testing done on these packages back in the 70s and 80s. However, the packages have gotten much, much larger since then. And there has not been full-scale package demonstration of them because the regulations don't require it, and DOE takes no issue with that. But we have observed that in other countries, namely the UK, public demonstration of the robustness of these packages. For example, in the 1980s, they had what's called Operation Smash Hit, where they ran a speeding train into a Type B package and then demonstrated that it was not breached as a result of that impact, really went a long way towards building public trust and confidence in the safety of transporting that material. And so we recognize in the US, there are a lot of public concerns about radioactive material in general and spent nuclear fuel and transporting spent nuclear fuel. And so we've included this package performance demonstration as part of our Consolidated Interim Storage Facility project and plan to start conducting work on it if we get funding in 2026. And we plan to put out a request for information in June or July of this year, geared towards a wide variety of audiences, including the general public, cask vendors, potential testing facilities, marketing and public affairs firms to help us sort of get the most public outreach of this activity. And to be clear, we are not certifying packages, or we are not second guessing the U.S. Nuclear Regulatory Commission's certification of these packages. This is really geared towards building public trust and confidence on the safety of these packages. So this is some ongoing work that we'll be starting some planning work on now, and more to come later. And additionally, I wanted to share some information resources if you want to get some more information or context on our program. We have our Curie website with the link here at curie.pnl.gov, where we have publicly available reports, presentations, and fact sheets if you're interested in getting more context for our program areas. Additionally, just last week, we launched a story maps tool for our program called Integrated Waste Management Story Maps. This is built on the Esri platform, and it's the first entry and just kind of walks you through the basics of what spent nuclear fuel is, how it's stored, transported, and eventually will be disposed of, as well as our consent-based siting process. And we have plans for more entries. So if this is a new topic area for you, then that story maps tool might be a good introduction for you. And that's all I have. Just Also wanted to highlight again, topic area 6, storage and transportation research, and topic area 7, overlapping with the consent-based siting team, is under my office.
We will move on to NE83, consent-based siting.
Well, hello, everyone. My name is Marlon Morales. As Erica mentioned, I'm the acting director of the Office of Consent-Based Siting. Next slide, please. So as you've now heard, will be the third time, the NE8 office has been recently undergone a reorg, and so NE83 is the Office of Consent-Based Siting. Our missions are, united in the sense that we're trying to implement a federal interim storage facility for commercial spent fuel through the consent-based siting process, which is what NE83, my particular office, works on. Next slide, please. So consent-based siting, what is it? What are we trying to talk about? The reality is that the nuclear fuel cycle, whether you're talking about active nuclear power plants, whether they're talking about decommissioned sites, shutdown sites, or facilities that are holding dry storage spent nuclear fuel, affect a number of people across the United States. A number of communities are impacted by these particular facilities. So in a consent-based siting context, we're trying to understand what is the demographic of these communities? What do these communities look like? They're not all the same, is the reality of what we're coming against. And we're looking to understand, how do we best communicate with these facilities? How do we best provide information for these facilities and engage them to be part of the process for a consent-based approach, which is where they're willing, able, and want to volunteer to host a future federal facility. Next slide, please. So consent-based siting really takes into account the people in the communities. It wants to understand what environmental justice is, equity in these particular locations. And it will always be collaborative. There's a misconception that facilities or communities that host nuclear facilities, whether again it's an active plant or decommissioned site or stranded ISFC, that they are anti-nuclear because they just don't have enough information about what nuclear is. They don't understand nuclear. And to an extent that may or may not be true. What we're coming to understand is that there's other components that come into play there. A number of communities may just want to be part of the process. They may want to be engaged and have a sense of ownership in understanding what's going on in their community, which is the consent-based portion of this. And a way to get to a community that wants to host a potential site is to bring them in along that process the entire way, which is what consent-based siting is really trying to do. It will constantly be evolving as more communities become part of this process. So it's intended to be adaptive. Next slide, please. So consent-based siting and our approach has been kind of broadly grouped into 3 stages. We have stage 1, stage 2, and stage 3. We're currently in stage 1, which is really the early stages of this. It'll be about 2 or 3 years. We're planning, we're building up capacity, we're initiating conversations with communities, and I'll get to that in just a little in a sec. But in no way at this point are we actually asking for volunteers. We are just trying to understand the landscape of what communities look like, what their interests are, what their focus are, how best to communicate and make them part of this process to encourage them to want to volunteer to be a future hosting site. Stage two, will be the site screening and assessment stage, and then stage 3 further down the line is going to be the negotiation and implementation stage. Next slide, please. One of the good things that we've been doing so far in this early process is we established a consortium, which is a DOE awarded 12 groups of folks a grant to go into the communities and understand what the layout was. So as you can see from this map, these are not only just the awardees, which are in green, but also their partner organizations. And you can see it covers the continental United States. We needed to understand what was going on out there. So the reality is that every community also communicates differently. So a push notification might work really well in New York City, but maybe not so well in Nebraska or Colorado. So how do communities want to be communicated with, and how do they actually communicate? So the consortia is establishing and gathering all of that baseline information for us as we go forward. Next slide, please. So some of the great work that they've been doing so far is they've actually had about 30 meetings, public engagement meetings where they've gone out to communities. They've added about 21 members. So as things go forward and they realize, well, this community has a focus or an interest in X, they then bring on experts in that particular topic so that they can better engage with those communities. One of the really great things we've been seeing is that with the awardees themselves, they have been putting money back into the community in terms of seed grants. So seed grants would go back into communities for things like citizen science and participatory science. So communities can have a sense of understanding what's going on and be part of the process going forward. They've also had about 20 different informational resource projects. Those could be leaflets, webinars, videos, any ways to then start communicating information. And again, is because we recognize that there are different ways in which communities do actually communicate. And 9 government engagements, whether that's tribal, federal, state. And it's really important to recognize there are a lot of players going forward. Not only is it covering the entire continental United States, but we're also just a lot of groups, and tribal communities are part of that group as well. Next slide, please. So there's a lot of information on the consortia and as well as the consent-based siting process. We're still very early into this process going forward. This is a QR code. We actually have a website we can go on and kind of look up what's going on with us right now. Essentially, we're trying to lay the foundations right now so that we can then have wider reaching, broader outreach going forward. The idea, again, is so that we can get a community engaged with us so we can move forward together to establish a federal interim storage facility going forward. Next slide, please. On that, and I should have mentioned, but right before I asked you to change the slides, on that consent-based siting webpage, there actually is an inbox as well. So if you had a question on consent-based siting, you could actually email that inbox and we could get back to you. Similar to what Erica just said, and you just actually literally saw this slide, we do have our repository of information. There's a lot of information out there on nuclear, on reaching out to communities. The story maps are a great starting tool. And again, the great thing about these story maps is that they are graphic. So you can, it's a different way of knowing information. And we're really trying to explore those different avenues going forward. Next slide. So we really thank you for this opportunity to speak on consent-based siting. Again, we're really excited about it. It's going to be a really important step going forward to establishing this. And if you have any questions, please feel free to reach out.
Great. Thank you, everyone who presented. We're now going to open the floor to questions.
Awesome. Looks like we have one question from about an hour ago. I believe this is for Frank Goldner. Concerning accident tolerance, does any have any activity related to reactors in war zones? For example, protecting against ballistic impact?
It's an interesting question, but the simple answer to that is no, we don't. We're working on enhancing the fuel capability under severe accidents, such as what happened at Fukushima. I'm sure in concepts that might be considered for such places, a successful work might be useful, but we don't have any activities at the moment.
Just so you know, on this idea of having reactors in combat zones or forward positions, the DoD is working on that, and they have that as part of DARPA. We don't necessarily support it. The NRC is looking into that. I would suggest that, this is Project Pele and things like that. We don't support that with our NEUPs directly. So if you are interested in such a topic, I would suggest that you look at the DARPA reactor development program, and we could answer your questions in the chat for later if we need to have you contact somebody that is in charge of that research for the Army and DoD. I hope I answered your question.
Thanks for the clarification, Madeline.
In the chat we have, it was mentioned that a consent-based consortia was already formed. For the FOA, is it still possible to get engaged in this topic of R&D if we are not part of that consortia?
Hi, this is Marlon Morales for the consent-based siting component. So the consortium, you are correct, the consortium is already formed and they're already doing that kind of groundwork. We do have other vehicles for engagement and for going forward for new topic areas and areas of interest. So I would encourage you to reach out to us and see what's available and see if we can collaborate on any future work. We are more limited going forward in the sense that the consortium is already met, but we do actually have other vehicles for funding.
Okay, we have another question. Is it possible to contact the program managers for the fit of a topic before the pre-application, and what is the suggested timeline? Is there a limit on the number of collaborator PI for R&D without the need to use a nuclear facility?
I'll take this one. This is Drew Thomas. The ability to talk with program managers, there will be an open opportunity on October 28th through 30th for a program manager question and answer session. That has yet to be announced, but after this webinar, we'll provide details on that opportunity. Program managers and other folks at DOE are not allowed to review pre-applications or other application ideas before the pre-application deadline. That review will happen as part of the pre-application process.
Drew, I think you said October. I think you meant
Oh,
May, right?
I meant May. Sorry, did I say October?
Yeah.
I meant May
Yeah,
28th through 30th.
yeah, May.
October might be a little bit late. So,
Good. All right.
what was the other part of the question, Josh?
Is there a limit on the number of collaborator PI for R&D without the need to use a nuclear facility?
No, there aren't limits on a number of collaborators. I'm not exactly sure what the nuclear facility might be referencing, so if you could clarify that point. But on any of these pre-applications, there's no limit on the number of PIs, co-PIs, or collaborators that you may need. That should be dictated by the PI on what resources are needed to complete the project.
There's only a limit on the amount of money that goes to non-universities. There is a limit there, of course.
Right.
Perfect.
This is
Thanks,
Madeline.
Drew. Yeah, go ahead, Madeline.
Just for clarification purposes, Frank and I are working on accident tolerant fuel claddings like Zircaloy with coatings and fecal coatings, and I'm dealing with silicon carbide cladding. And in the materials portion of what Steve Kung presented for NE43, he also mentioned cladding. So I was hoping that Steve Kung could clarify, if possible, what his research involves in terms of cladding, and how it is, separate or distinct from what we're doing in the accident tolerant fuels and silicon carbide cladding research, so that folks can understand that we will have a distinction, so that the PIs can put their applications in the correct bin. So if Steve would like to answer that, that would be great.
Madeline, I'm not quite sure we are covering the silicon carbide at this time. So I think there will be a separate
I'm sure you're
program.
not,
There will
but
be
the
a
idea
separate
here is,
program. Yeah. At our program, Innovative Nuclear Material Program, cladding for focus on mostly the advanced cladding material for fast reactor or the whatever advanced reactor application. So
like
details.
the ODS steels and things like that.
Yes, that's part of our
Okay.
program. Yes.
Okay.
We are funded by that area. So.
Okay, just so everyone knows out there that they need to read the paragraphs very carefully to make sure their concept for the NEUPs and the other research fits into the right paragraph. Thank you.
It's not a major concern from my perspective. Just feel free to submit it, and then we will decide internally at the headquarters to decide how to bin each proposal. That's not a major concern. If I were a PI, I won't worry that at all.
Awesome. Thank you, Dr. Kung. All right, the next question, are there any published statistics for awardees of CINR funds, maybe by career level, tenure, research tracks, R1, R2 universities?
I could take that one. This is John Gilligan. We do present to nuclear engineering department heads some of those statistics, breakdowns of those kind of summary awards and where they go to at various levels and so forth. So that is done, but we don't publish it, so to speak, although the nuclear engineering department heads do get a PowerPoint presentation And maybe we could put that on our website at some point if that's of interest for everybody, because that is open information as far as I know. But yeah, that's the only stuff that's really published regarding that.
Right, thank you, John. Another question just came in. Is research regarding structural materials concrete for nuclear facilities covered by cladding materials or other programs?
Definitely different program there. For the cladding material, only for the in-core material and the cladding. So the structure material will be a separate program managed mostly by Suleska into the structure in the material program. Just for your information, don't worry about which part under what. Just provide the best idea, the brightest thoughts there. So then we will internally decide how to bring them. No worry about at all. So which program, how to manage it internally. We will decide it internally how to bring them.
And Stephen, that's a great point. One point that I will make as we get into the CINR presentation, and if you've looked at the broad topic areas, there is just a general area on materials. And so you can think, as Stephen said, you should look for which of those general topic areas best represents the overarching concept that you're proposing and submit it there. If there is consideration of potentially moving that to a different topic area where it would be, fit a little bit better, that's a process that we will take care of, as Stephen said, internally here at DOE with the principal investigators' permission and buy-in on any changes that may take place there.
Awesome. Thanks, Drew. Next question, is there a way for the PIs to find the numerical rating and rank of their proposals?
The short answer to this is no. Comments are provided back to principal investigators on both their pre-applications and full applications. Ratings or numerical ratings or any of that type of information is not something that's released to the PI or to anybody else.
Let me just add to that just a brief little bit, Drew. If PIs I can talk with PIs about the relative competitiveness of their proposal. If you want to contact me, this is John Gilligan, on anything specific, but I can't give numerical or other kind of detailed information like that. That's what I've done in the past. So
great, thanks, John. Looks like we have one more before we move on. For the fiscal year 2025 consolidated innovative nuclear research topic areas, what is the due date for proposals?
We'll get into this in our next presentation that will start in about a minute. But as long as the FOA releases along the timeframes that we have planned, we'll be looking at late June. So you'll see those exact dates if we are able to release the funding opportunity next week, which is the target. So we'll get into some detailed slides here in a few minutes.
Okay, thank you everyone for your questions and for all those who participated in helping us answer those. We are going to move on to the next part in our agenda, which is the CINR FOA overview. We're going to start off with handing it over to Program Manager Jenna Payne.
Hi, good morning, almost afternoon, everyone. I'm Jenna Payne, and I'm with NE's Office of External Innovation. I serve as the Federal Program Manager for the Consolidated Innovative Nuclear Research Funding Opportunity Announcement. Just wanted to say a quick thank you for joining us today as we provide you with some tentative dates and policy changes and reminders for fiscal year 2025. With that, I want to keep it brief. We have quite a few slides to go through. So I'm going to pass things along to Drew Thomas, who will walk us through the FY25 CINR FOA. Thanks, Drew.
Just getting the slides going here, and we'll get moving. So the plan for today is to spend the next hour or so going over the CINR funding opportunity. This is the largest funding opportunity out of the overall university program portfolio. We'll get through as quickly as I can all of the slides, then I'll invite John Gilligan, Jenna, back to the question and answer, so we can answer any of your questions that you have over the course of the presentation. So just as a reminder, please go ahead and raise your hand if you want to ask a question. You can ask one live. Josh can unmute you, or you can ask through the chat function. Either one will work. And I'll get right into the presentation. For a lot of you, this is probably repetitive, but what I'm going to try to do is highlight major policy changes, major changes from last year's funding opportunity. For those of you that are new, this should serve as a pretty comprehensive overview of the funding opportunity. As Aaron mentioned at the beginning of this webinar, please do reference the funding opportunity once it comes out. These slides are to provide you as much information as we have. We don't have a final released version of the funding opportunity yet, and there is a possibility that that items may shift and change in that final version. So we'll provide you an overview, keep providing you information as you apply to this opportunity, but just keep in mind that as the FOA comes out, that is the place to look for any of these details. So we're going to get right into what the CINR FOA is and its objectives and priorities. So the CINR FOA broadly supports the DOE Office of Nuclear Energy mission, which is to advance U.S. nuclear power to meet the nation's energy needs. That is really through three different thrust areas. The first is enhancing the long-term viability and competitiveness of the existing reactor fleet, developing and deploying advanced reactors in that pipeline, and implementing and maintaining a national strategic fuel cycle and supply chain infrastructure. And so as you saw these office director presentations, which I want to thank everyone for providing, that really gives you an idea of how DOE overall is trying to meet that three-pronged mission. And in those spaces, it's really that those presentations were really intended to give you an idea of what DOE is working on, what DOE is focused on, and how the programs are structured. You'll notice as we get into the CINR FOA that the topic areas don't necessarily track directly to those offices or to those research initiatives, and that's intentional. The reason for that is recognizing the space that the university community has to play in our research and development portfolio. Those spaces may not align directly with one of those program initiatives or one of those things that's happening in the national lab system. And we want to be able to entertain those ideas, evaluate those ideas, and reward innovative or groundbreaking concepts through our university research portfolio. So all applications submitted to this FOA must have a strong tie to one of those three areas. And the reason why we gave you the office director overviews is to give you a broader idea of what those areas mean. And the idea here is that we're going to conduct cross-cutting nuclear energy research and development and provide associated infrastructure support and student support to develop innovative technologies. The idea there is to dramatically improve performance for DOE and its mission and to maximize both the student impact and research impact of DOE resources. There are a few changes. These will really reflect some of the changes that happened last year, but we continue to change the topic area structure by consolidating different areas. You'll see a full breakdown, and I hope you've had a chance to look at the overall topic area document, the draft document that was put out last Friday or last Thursday. But an example of this, like I mentioned earlier, is pushing together all of our materials areas into one scope. And so you'll see some slight changes from last year that are really intended to broaden those scope areas and increase the flexibility of that topic area structure. There are some expanded blue sky opportunities. There's still our strategic needs blue sky area in R&D, but you'll also notice that there is a new IRP added, which is a grand challenge for advanced reactor spent nuclear fuel disposition, which brings that broad topic area into the fold of our IRPs. Let's go over the 2025 due dates, which I'm sure everybody's interested in. I will predicate this entire slide on the fact that we have not yet released the funding opportunity. And so these dates may change or may slide depending on when that final release of the funding opportunity comes out. Regardless of when the funding opportunity comes out, I would encourage you to start building your research teams for your pre-applications. You have the draft work scopes. They may change, but typically they change in smaller ways. And so I would encourage you, regardless of whether the funding opportunity is out next week or whether it's out in 2 weeks or further along, that you start preparing your pre-applications with the information you have here, so that as that releases and any deadlines feel short, that you've already prepared yourself for responding to the funding opportunity. So we anticipate or are hoping for a release the week of May 13th for the CINR funding opportunity. That's next week. And like I mentioned earlier, not October, but May 28th through 30th, a topic area program manager question and answer will bring our program managers and our technical experts together in each of the topic areas that we'll be proposing this year. And those individuals will have an open question and answer type format that's going to be run by over Microsoft Teams. For anybody that has questions about what DOE's activities are in those areas, how to get more involved with national lab, collaborations or researchers, any clarifications on the fit of a particular idea could be clarified there. So there's an opportunity there at the end of May to interact with program managers. If you're not able to make that opportunity, it will be recorded and put out on NEUP.gov, but I'd also like to mention that you can always email the NEUP integration office, and we can facilitate a conversation, an email conversation between our technical experts and program managers and you, in a way that we can record those responses and provide them to the general public. Ultimately, all of our program manager interactions are intended to be publicly available. And so we'll try to use a process that captures all of those questions, all of the answers, and provides them to the general population that's going to be answering the funding opportunity. For the LOI, NSUF LOI due date, it's anticipated for June 5th. Pre-applications end of June 26th. And then a couple of other dates here. August would be statements of works for NSUF scopes. September will likely be invitations for our full application process. And then we'll be collecting applications by mid-November to finish out the full application process. Happy to answer any questions, more detailed questions about due dates or anticipated due dates as we go. So let me break down the FOA organization. There's really 3 different areas of the funding opportunity that are captured in what we call Appendix A, B, and C. Now those appendices are really intended to provide you topic areas for each of these, but we use that Appendix A, B, and C structure to really describe the following 3 things. For Appendix A, that is the NEUP university-led R&D. So that's the university program R&D, our strategic needs Blue Sky R&D, and our university R&D that has NSUF access components. So you'll see and hear the moniker NSUF1 as our university R&D and NSUF access component. What that means is that you can request NSUF access for an irradiation or PIE type activity. And you can also request an R&D budget through the NEUP program to be able to perform some type of R&D either before or after that NSUF access takes place. For Appendix B, that is our university-led integrated research project category. And there are 3 areas that are grand challenges for our integrated research projects. Those IRPs are large, up to $3 million projects. We'll get into some details about what the requirements are for each of these areas. Finally, we have Appendix C, which is our NSUF access only. You'll also hear the moniker NSUF2 for this area, and that is requesting access to the NSUF suite of partner institutions and facilities. And that can be requested either by a university, national laboratory, or industry lead PI. And so the first two, only university-led with national laboratory and industry collaborators. The Appendix C is for anyone to lead for access to those NSUF facilities. So, and as I'm seeing chat as we go, yes, these slides will be made available, and there's further presentations on all of these overviews that I'm providing. There's a full NSUF overview presentation to understand a little bit more about that process as well. So there'll be more if you're needing more information. So as I mentioned, the research elements are really separated by these appendices, but there's different objectives for each of these different research elements. For the university program R&D, they're organized based on topic area. There's an interest in innovative ideas that address technical challenges in each of these topical areas. And in a lot of ways, you can think of that R&D program being more of a traditional incremental style R&D program where the awards are up to $1 million over 3 years. And they're going to be in a wide variety of different topical areas. The strategic needs blue sky R&D is a separate section, a separate topic area in that grouping. And the idea here is that we're supporting key nuclear engineering topical areas that are critical to advancing continued research and education in those spaces. And those, you could think of those as being more fundamental style topics like reactor physics or chemistry or maybe thermal hydraulics or heat transfer, those types of topics that may not be covered as directly in some of the applied topic areas that we have, above the strategic need blue sky. The IRPs are larger, more what I would call more consortia style projects. They require multiple universities, multiple institutions. And the idea is that there's significant projects focused on addressing a grand challenge, major technical gap. And so the idea is after that 3-year period that we're talking about, more of addressing a specific gap or grand challenge where you've got some type of a solution or path forward that can really be described there. Let me go over the R&D topic areas. You'll notice that there's 14 total areas. 2 of those are NSUF areas, and so they're eligible for NSUF access. Those are NSUF 1 and NSUF 2. You'll notice that those don't have very specific technical descriptions, but do describe kind of the idea of what NSUF's mission is, which is materials focused. The other 12 areas are really spread out across the entire mission space. And so as you read through these descriptions, you'll probably be able to make some parallels between a lot of the presentations that you just heard the office directors make. Some of those are, reactor development or plant optimization, nuclear fuel recycling technologies, fuels, cybersecurity, consent-based siting, all of those types of areas. And so if you have specific questions on these topic areas, I'd encourage you to read the draft document and then come prepared at the end of May with questions for our program managers and our national technical directors on any specifics that you need to really be able to develop a strong proposal. So let's go over the specifics of each one of these different types of awards in Appendix A, B, and C. They're organized in that strategic way that I just told you about, but they're also organized this way because the rules for applying for each of these different categories are similar. And so I'll go over the Appendix A university-led R&D area first, about award size, period of performance, those types of things, and eligibility. So first off, when I say university-led R&D, I'm talking Appendix A, I'm talking about topic area 1 through 12 in NSUF 1. That though the overall ceiling for those applications is up to $1 million, with the exception of strategic needs blue sky, which is up to $500,000. It's anticipated that there's going to be several projects that are under the $1 million mark. That's a ceiling, not a requirement. And so there's it's anticipated that there will be several less than $1 million projects, potentially awarded. So don't think that because we said it's up to $1 million that you have to propose $1 million. What we'd encourage you to do is take a look at your project and your scope and propose the appropriate amount based on the scope and the collaborators that you have to be able to accomplish that work. That will be seen just as favorably as a full $1 million application. There is a research experiences for undergraduate program that we started running last year, and there is an opportunity in this Appendix A to provide a $100,000 supplement, or request, I should say, not provide, but request a $100,000 supplement on top of that $1 million or $500,000 maximum to run a research experience for undergraduate program as part of the project. And so for those familiar with NSF's REU program, this would be something that would be equivalent to a project-based REU, not necessarily a site-based REU. So period of performance is up to 3 years, and there's a couple of eligibility requirements to go over quickly. And I'll go over a more detailed eligibility section a little bit later. Universities are eligible to lead. National laboratories, universities, and industry are eligible to collaborate. NSUF1, like I said before, is R&D with NSUF access. And those applications are open for universities to lead, and national laboratories and industry can also collaborate on those. For an estimated level of funding, we estimate there's going to be approximately $49 million for this area, which we think will amount to about 50 awards. And there's approximately $2 million for REU supplements, and that will result in about 20 REU supplements. And I'm happy to say that in its inaugural year, that we did award all 20 REU supplements as part of our award packages that are being negotiated right now and were announced last month. Okay, let's go to university-led IRPs. So the award size is larger for these, as I mentioned, up to $3 million for each of these opportunities. There are 3 accelerating reactor deployment, advanced reactor spent nuclear fuel disposition, and then a grand challenge for research and development at minority serving institutions. They're each up to $3 million requests. These applications are also eligible for an optional REU supplement of up to $100,000 if you choose to do that as part of this project. So from an eligibility standpoint, very similar. Universities are eligible to lead. Universities, national laboratories, and industry are eligible to collaborate. For teaming, this is slightly different than the other area, and that teams should consist of, at a minimum, multiple universities. And so there's a requirement that multiple universities are part of an IRP team. That is a minimum requirement, and we typically see broader collaborations as part of these larger budgets, larger projects. International collaborations are encouraged, although there aren't any specific international collaborations named in the funding opportunity this year. And we'll go over some rules for international collaborations a little bit later in this presentation. I do want to mention that IRP3 has special eligibility criteria to be able to apply for it and what the teaming requirements are for that. I would encourage you to read in detail, if you're interested in that opportunity, what those requirements are. It does require that 80% of the proposed budget goes to MSI identified institutions, with 20% being majority institutions or national laboratories or industry being a supporting partner of up to 20%. So there are some different rules for that IRP3 scope that are important to walk through if you're considering trying to apply to that IRP scope.
Drew, there's a question that's come up a couple times. I just wanted to make sure you answered it. I saw it. Apparently in the work scopes that were sent out, the Blue Sky was set at $1 million. I don't think it's supposed to be $1 million. I think it's still supposed to be 500K limit. Is that not right?
Yeah, my understanding is it's supposed to be 500K. So that must be a typo in the draft document.
Typo. Sorry about that.
Yeah.
That's something will get changed. It just slipped through, and that's why we call them drafts.
Yep. Thanks, John. Thanks for that. And we'll get, I see that there's a lot of questions opening up in the chat, which is great. We'll get to those at the end of the presentation. So we'll get through as many as we can before we run out of time. So let's go over Appendix C next, which is the NSUF2 area. The award size is unknown. The NSUF office will provide access values and those are defined by a final cost estimate that happens as part of an iterative process with the NSUF office to understand what the scope of your project might be, what facilities are available, how much that activity might cost through a formal cost estimate. And so there's some items there where you don't necessarily need to worry about award size. That's something that you should work with the NSUF office about, and they'll make an ultimate determination on what that cost would be. The period of performance is typically up to 3 years, and there is some flexibility in this space of up to 7 years if irradiation and PIE combined are proposed. These applications are, like I said before, open to universities, national labs, and industry leads and collaborators. And one of the important aspects of NSUF2 access-only funding is that applications must identify or have established R&D funds from another source. And so you can think of that as an existing NEUP project, some other funds, industry type funds or whatever else, but those funds do need to be identified. And there's a couple of requirements that we'll go over here, and Brendan and Chris Barr will review as part of the NSUF presentation to give you some details about what kind of letters and those types of things need to be in hand to be able to give DOE confidence about the ability of the project to succeed. So the estimated number of awards here is estimated to be around $6.5 million in total NSUF access. That amounts more or less to about 8 awards based on the way these things have gone in the past. And so we may bring Brendan or Chris in for some of the NSUF questions if they'd be better answered there. But we'll move on from the overall structure of the funding opportunity and talk a little bit last about NEA NEST opportunities. So the NEA NEST is the Nuclear Energy Agency's Nuclear Education Skills and Technology Program. It's an international program that DOE is supportive of. And there are opportunities potentially to send students, get participation in this NEA NEST program through the CINR projects. The idea here is not that NEA NEST is evaluated as part of the project, but we would like you to identify in one of these 3 topic areas, if you propose in these spaces, topic area 1, 10, or IRP 1, that you have interest in participating in NEST. If that's the case, after a project is awarded, DOE can get you in contact with the NEA NEST representative, and so that you can coordinate in those spaces. But that's an opportunity that we support here and want to make sure that that folks are aware of it and identify that as a potential additional opportunity on their project if they see fit. All right, that's objective 1 finished for this presentation. Number 2 is on our REU program. This is called Research Experiences for Undergraduate Supplements. As I mentioned, these are supplements for R&D awards, and so they're going to be attached and integrated into the overall performance of the research. And the idea here is this is feedback that we received from all of you several years ago that oftentimes because of the level of funding and everything else, that it's really difficult to choose. You essentially have to choose between an additional graduate student, for example, and supporting undergraduate research. And so to remove those barriers, we created this REU supplement program to promote undergraduate research opportunities in any research and development. So What we're doing is really incentivizing undergraduate participation in projects through really two different formats. Like any RU program, this is really intended to provide training experience and research experience for our undergraduate cohort, which is critical, we understand, to drawing in new undergraduate research, individuals potentially through the system, but also maybe into graduate school. There's two formats that we've identified for this REU style program. One focused on campus students. That would be structured for a specific duration, maybe like a semester, that's focused on project activities where the undergraduates are paid on an on-effort basis. And secondly, maybe a more traditional RU summer style program that supports off-campus students from other universities for a specific duration. And the idea here is that both of these efforts really should focus on underserved communities and students, either on campus or targeting students that may not otherwise have nuclear energy research opportunities. For example, at institutions that have strong engineering programs but don't have nuclear engineering faculty or nuclear focused faculty. Those would kind of be the focus here for the REU. Both formats are acceptable from those standpoints. We really leave it up to the PI to define what the specific needs of the project are in this space to make these types of programs successful. So like I mentioned before, all Appendix A university-led R&D and all Appendix B IRP areas are eligible to apply for an RU supplement. So I mentioned a lot of these pieces and parts, but there's a couple of things to mention for this supplement. The proposed REU is an integral part of the overall application, and so it's not reviewed separately. It's received and evaluated as part of the overall application. It is optional, which means there is no clear benefit or disadvantage of deciding to do an REU program. Obviously, it could enhance maybe your teaming or your capabilities of the project, but it's not a requirement. And so we get that question often of, is my application going to be looked down upon because it doesn't have an REU? The answer to that is no. It's going to be based on the overall merit. The evaluation is going to be based on the overall merit of the application, not just on an REU component. So there are a couple of new application requirements to be aware of. These are new as of last year, so they should be familiar to those that applied last year. There's a checkbox on the pre-application phase to indicate your interest in an REU. That is not a binding requirement, meaning that you could choose to do an REU at the full application stage if you didn't check that box, or choose not to do one if you did check the box. It's just to give us an indication of how much interest is there in the overall program at the pre-application stage. At the full application stage, a full REU plan, which is up to 5 pages, is required to describe where the overall budget is going to be spent and what activities will take place. As part of that application, we would like to remind you in your budget justification and on the application form that we would like you to clearly differentiate what REU activities and the associated budget are from the rest of the overall R&D budget. That's something we took away from last year, trying to understand how those broke down, and it was challenging in some cases. So please do that. We do understand that details of an REU plan and how it's going to be implemented may change during the award negotiation phase and over time. And so what we would like from that REU plan is, a best developed proposal that you can get, understanding that some of those details may have to move and change as we go forward. So adjustments are expected, right? The idea here from an overview standpoint is that PIs are responsible for developing the opportunity that best supports their project. So if you look at the REU language as it comes out in the funding opportunity, it will be intentionally broad. It will be non-specific, and the idea behind that is design a program that's going to best impact undergraduate students for your specific approach. If you're an experimentalist or a modeler, or if you're doing something that's that's a little bit more challenging because of sensitive materials or other things like that, or irradiated materials, then you make adjustments based on whatever those factors are to best support undergraduate programs. The idea here is that an REU is a research training experience paid via stipend. And so you can have a REU program both at the lead institution or potentially a partner institution. It's just recognizing how those costs are categorized as part of that REU program, which will be outlined in the FOA, but it's typically known as like student support costs or something like that. Further guidelines. RU activities can't exceed $100,000. The term of that RU supplement cannot exceed the term of the project, so it has to be done within the same project timeframe. And like I said, the RU portion is expected to fall under participant support costs as defined by 2 CFR 200. And so that is how you would define those costs, whether they're the lead institution or potentially a partner institution. And the total cost for a summer RU program, anything that includes allowable direct and indirect costs is allowable, as long as it's comparable to other programs like the NSF RU program. If there's exceptional circumstances, those can be extended to DOE for consideration and approved on a case-by-case basis. One common question we've gotten from the REU supplements as we went through last year was if a national laboratory style internship program would be considered an REU opportunity or something that's off campus. The guidance we've provided in that space, you can look at our questions and answers for the REU program, is that this is intended to be a university research focused research experience for undergraduate program, meaning, of course, ask questions if there's specific questions in this space, but these should be at a lead or partner institution, a lead or partner university institution for these experiences. All right, let's talk about REU student eligibility. So there's a couple of guidelines here. Students must be U.S. citizens, nationals, or permanent residents. They need to be a true undergraduate student. And what we mean by that is they're enrolled in a part-time or full-time associate's or bachelor's program. They're transferring from one college to another, and they aren't technically in either program over a summer. That's okay. They'll still be a degree-seeking student. High school students that have been accepted and have already been accepted into a university are eligible. Students who have received their bachelor degree but have yet to start graduate school or a job or other things like that would no longer be considered undergraduate students and would not be eligible. All right, I think I got through our REU slides here, and we'll move on to policy updates and reminders. A lot of these will be repetitive for everyone, but I put a slide together up front on major policy updates. These are things that have changed significantly since last year's CINR FOA that I wanted to walk through. So we already talked about the topic areas being changed and broader, and NSUF1. So those are things that we've already talked about. I want to remind everybody about our collaborator designations. This is getting pretty far into the weeds, but is an important point to make as you fill out your paperwork. Collaborators have two different designations that are very important about how you prepare your paperwork for your application. Those collaborator designations are senior and key personnel, and other collaborators or personnel. Senior and key personnel, that's at your discretion. The idea is these are individuals that are typically receiving funding or making major contributions to the project. Other collaborators or personnel typically don't receive funding and may have advisory roles or a non-major portion of the project. The idea is Senior and key collaborators, we need all of the documentation that is identified in the FOA. Other collaborators or personnel, some of those documents are exempt from, some of those document requirements are exempt for those folks. And we'll get into, some specifics on the documents that are required in just a moment. We do have a change to our PI move and institutional change guidance. This is due to DOE's Guide to Financial Assistance revision in section 4.2.8. If you're, a policy nerd like me, maybe you'll go read that. But what it really says is that on a case-by-case basis, DOE can work with PIs to move awards from a lead institution to another lead institution with both institutions' approval. And so we're allowing a little bit more discussion and space in that PI move and change policy. Those guidance requirements are changing as of this year. For no cost extension requests, this is also changing in that as we've moved up our application and our review schedule, there's a more limited need to understand no cost extensions early. And so we're moving this back to requests in NCE as soon as you know that you need it, but no later than 90 days before the project end date. And so those are some major policy changes for the FOA as we roll it out in the coming weeks. I'm going to go over just some, this is getting down into the weeds, but some important things. These are all things that we are, as we work through our initial review of all of these applications, we constantly catch. So even if this does sound repetitive or anything else, these are things that we see every year and want to warn you about them because it causes confusion sometimes and unneeded stress, I guess, when we give you about 24 hours to correct these things in certain circumstances, or in certain cases, we're forced to dismiss an application because of noncompliance. So for policy reminders, formatting and fonts and page limits. So font sizing is applied to all pages. That includes references, that includes everything except the one space that we have a little bit of flexibility on are graphical elements like axis tables, legends, or those types of things, which we recognize you can't control the exact font size on those. This may seem silly, but the idea is that we provide the exact same amount of space to every single applicant, regardless of what you are doing, to make your case for an application. And there's a fairness consideration here to make sure that everybody has the exact same amount of space to make their case, and that those restrictions or those constraints are the same for everyone. That means that the page limits are strict and the font requirements are strict. And this has led in the past to either major revisions, meaning a truncation of cutting off a certain amount of content if it exceeds those page limits. And at different times over the years, potential dismissal of an application if we can't really find a way to get that application out to review in a format that's compliant. Technical narrative page limits are the following for Appendix A. 5-page pre-application, 10-page full application. If you're in the NSUF1 area, it's slightly different because you'll need to describe your NSUF access. So that's a 2-page letter of intent, 5-page pre-application, 15-page full application to fully describe the NSUF capabilities you'll be using, 50-page IRP, and NSUF2 matches NSUF1, which is 2-page LOI, 5-page pre-application, 15-page full application. Okay, let's talk about application submissions. All applications are accepted through NEUP.gov's website. You can see right here with the red line that you sign in on the top. You'll go to the application portal where you'll need to create a new account if you don't have one already. If you already have one, you can go ahead straight into your login and get started. Once you get in, you'll sit on a landing page which has a dashboard on it, which talks about your open applications, your reviews, gives you an idea of all of those different types of metrics. But you can go on to the applications tab, and that will open the current calls. You'll see any open calls that are available and their end date. I will warn you, we get people submitting the last 30 seconds of these due dates every single year. Those due dates and those due date times are listed in Mountain Time, and they are strict. And so if you do have any issues with the application system, give one of our staff a call or email the NEUP@INL.gov inbox. We can help you if we know there's an issue, if there's a technical issue before the deadline. And so it's just really important if you're having any type of login issues or any type of issues with the application that you directly contact the contacts in the FOA to get some help rather than trying to do it all by yourself until the deadline runs out and then making a request afterward. It's much easier to help you before the deadline passes than afterward. For accounts and submissions, a couple of reminders. Lead applicants must have an account on NEUP.gov. A research administrator may create and submit the application, but that application must be tied to a lead PI account. The application must be submitted by the lead institution. So we often have co-PIs or collaborators help PIs prepare applications, but the co-PI from another institution is not allowed to submit a pre or full application on behalf of another institution. The PI or designated representative, like a research administrator or office-sponsored programs, must submit that application from the lead institution. Applications are considered submitted at the pre-application or LOI phase. And so even if you haven't provided, official, OSP style documentation like the DOE government forms or other things like that, you do need to follow these rules as you go forward. We cannot accept applications that are submitted by one institution on behalf of another institution. It's not something that's possible. And so just as a reminder, don't get into that space where you're submitting on behalf of a different institution. Materials required by the FOA are required by the published deadlines. Any material not received or not available at that point may not be considered. And so just recognize that if you have revisions after the deadline or other things like that, they're likely to not be considered. So please, plan early. Make sure you're not doing this, the last hour before the deadline. Okay, some other account and submission reminders is all institutions are required to have a unique entity identifier and register on the SAM website. This will be requested during the full application stage as part of the SF 424 application form. And all CINR applications are required to provide a list of publications from previous CINR projects when they submit their pre-application. This is a requirement for the lead PI. The idea here is that we're trying to collect in a non-invasive way, trying to collect the publication output for our NEUP projects for those that participate regularly. And so we would request as much information as you have that you can put together in a reasonable amount of time. For your co-PIs and collaborators, we would love to have that information, but the requirement is for the lead PI and any publications that they produced as part of their previous CINR supported projects. PIs and collaborators, the team is considered final at the pre-application stage, and any changes to that team will need to be approved by DOE's contracting officer. You can do that by contacting the NEUP office at NEUP@INL.gov and getting approval for any PI or collaboration changes. And last but not least, the PI is responsible for the selection of the topic area. Do your best. The pre-application, wherever that's submitted, that's where the full application will go. And there is a process that we can go through to, after submission, understand if maybe it was submitted to an area that it would be less competitive in. How we switch and change that will be driven by our DOE program managers who feel like, hey, this application has a better chance in this space. If we do that, we'll always directly contact the lead PI for approval. It's not a requirement to change a topic area if you feel like it should be somewhere for some reason, but we'll provide those suggestions as needed. One of the most common questions that we get is how you submit your application across topic areas if you feel like it's cross-cutting. The idea is pick one topic area. One application should only be submitted to one topic area, not the same application to multiple topic areas. If you do that, there's a likelihood that all of those applications will get dismissed if they're identical. And so the idea here is select as best you can. Know that DOE is going to look over it and make sure that it's in the best category possible, and only submit one application. Each application you submit should be a unique and separate and different idea. All right, let's go over NSUF applications really quickly. This is just a reminder, once again, of the eligibility requirements. There's a couple of pieces for NSUF that Brendan and Chris will go in more detail with you. NSUF requires a user agreement, and applicants are required to affirm their ability to sign and accept said user agreement on submission of the LOI pre-application and full application. That is for lack of a better word, the contractual mechanism that NSUF uses to be able to execute the work. And so it is a requirement to be able to successfully negotiate that access. NSUF statements of work are uploaded onto the application forms. Details on how those are uploaded will be in the FOA, but those due dates are also strict, and so applications often get dismissed if those statement of work deadlines are not met. NSUF applicants must also provide letters, as I alluded to earlier, confirming access to materials and R&D funds if necessary, if there's R&D activities associated with the work. Let's go over to eligibility next. So for eligibility, there's a couple of pieces that I think are important in general, and then we'll get into some very specifics about the different appendices. The first is you as the applicant are responsible for reading these eligibility limits. If you don't understand them or feel like they're not clear, please reach out to someone in my office and we can provide that clarification to you. There's a couple of key points here. For a university-led R&D project, there's often a question about university affiliations. We have a policy that to be considered faculty, you need to have more than 50% of your salary and benefits paid by the university. That means that we intentionally exclude lead PIs as university individuals if they're on adjunct appointments, joint appointments, or other similar arrangements that are similar to those. The idea is our university program should be led by university faculty members, not by national lab folks on joint appointment or other things like that. And so that's where that policy comes from. The other big overarching reminder is that we have other funding opportunities that we're going to talk about later today. They have their own eligibility requirements, and this funding opportunity has its eligibility requirements. So I just want to remind everybody as we go forward, everything that I talk about here is applicable to CINR funding opportunity awards and CINR funding opportunity applications. Phase 2 continuation projects or DECP applications or other applications as part of the overall university program portfolio have their own eligibility descriptions, which will be described later. So let's talk about a couple of more overarching concepts, and then we'll get into the specifics for our university-led programs, which have relatively complex eligibility requirements. I'll walk through those and then be happy to answer any questions. The idea here is that a university PI can submit 6 pre-applications with no more than 3 as the lead PI. So 6 total, no more than 3 could you be the lead PI. So that could be 3 and 3, that could be 1 as lead, 5 as a co-PI. That doesn't matter, but it can be no more than 6. A PI can also have no more than one IRP or 3 active R&D projects. And you can't submit more than the number of full applications than you would be eligible to win. So if you are an active PI who has 3 running NEUP R&D projects that are all still running by the end of next year, December 31st, 2025, that this restriction is in place for you. These are rare cases, but the idea is that you've got a lot of work going on in this program already, and to let you focus on that work. PIs can't submit the same application to 2 different topic areas. We just talked about that. And NSUF2, the access only component, is not bound by these eligibility restrictions unless it's specified specifically. And so the idea here is that these eligibility restrictions are really on R&D funding, not on access. So let's get into a couple. Applicants are ineligible to lead an R&D project under the PI has a currently funded IRP project that's going to be active after December 31st, 2025. If the PI has 3 or more R&D projects that will still be active after December 31st, 2025, that excludes NSUF2 projects, or the PI has a no cost time extension on an existing CINR award, excluding infrastructure, that will still be active beyond December 31st, 2025. That also excludes extensions provided that are required because of access issues through NSUF. So those will be dealt with on a case-by-case basis. For integrated research projects, this one's a little bit more complicated. So I'm going to summarize this in what I think is an easy way, and then we'll read through all this so you can understand. Ultimately, the idea is if you want to apply for an IRP project, or you are a lead PI on an IRP project, that you would be eligible to only submit 1 R&D project in addition to that IRP. So we understand that IRPs, the topics change every once in a while. It's not as maybe stable as our overall R&D portfolio, and so there's some concessions given in those spaces. So let me get down to the nitty gritty here on kind of what that means. For IRP applications, this is if you are the lead PI submitting to an IRP applications, you would not be able to under the following circumstances. You have a currently funded IRP that's going to be active after December 31st, 2025. The idea is you don't have 2 IRP projects running at the same time under you as a lead PI. That you have 3 or more R&D projects that will still be active after December 31st, 2025. That you have a no cost time extension beyond December 31st, 2025. So those are the same as the slide I had before. These next 2 are the ones that are specific to the IRPs, and that is the applicant is designated as a PI for more than 1 currently funded NE project that will be active beyond December 31st, 2025. So the idea is if you have 1 R&D project that's active, you can still choose to apply either for the R&D portfolio in Appendix A or an IRP. But if you have more than 1 R&D project that's going to be active after that time frame, the idea would be that you would not be able to apply for an IRP, and you probably put your efforts over in the R&D area. The last thing here is that if a PI chooses to submit an IRP application, let's say you're a PI that doesn't have any NEUP or CINR project funding, then you could do an IRP and 1 R&D application as part of your application package overall to this funding opportunity. I recognize that that's a little confusing if you're thinking about applying for an IRP and you don't understand what I just walked through. Like I said, please reach out by email and we can walk you through those requirements a little bit better and talk about your specific funding situation through the CINR or NEUP office and provide you a little bit more guidance there. All right, let's go over some document requirements. These are the full application documents that you'll be able to see when the funding opportunity announces. But I want to bring to your attention a couple of different things. You'll notice that in this required forms table, there's a description of who is required to provide those forms. You'll see What I want to bring main attention to in these two slides is you'll see when it identifies senior and key personnel. Oftentimes, the places where people get caught up most are how to handle national laboratory funding. For senior and key personnel, there are two requirements for national lab funding. That's a field work proposal, or an FWP, and a letter of authorization from the DOE authorized contracting official, or the cognizant DOE contracting official for that site office. Regardless of whether there's funding going to a national lab partner or not, whether they're in the senior and key personnel or whether they're in the other collaborator section, a letter of authorization is required from the cognizant DOE authorized contracting official, regardless of whether they're getting funded or not. So just recognize that that is a requirement that you'll need to anticipate, and each national lab manages that process differently. And so you'll need to make sure that you engage in that process early and often with your national lab collaborators to make sure that they don't get excluded, or that they aren't authorized to work on a CINR project. You'll notice that there's about 15 or so areas or documents that you have to provide for a full application. It's much more simplified for our LOI and pre-application process to really focus on technical narratives, CVs, capabilities documents, those types of things. Once again, if you have questions about the full application requirements, the application portal provides detailed instructions, and if you have additional instructions, we have staff here on site that can help you walk through the application process. Let's go over collaborations really quickly. For our collaborations, we will get into the review criteria soon, but we do give additional consideration for collaborations with minority serving institutions. And so that's something we'll get into more detail about how we actually evaluate these applications, but that's just a reminder that those receive additional consideration. The other main piece on the collaborator part is that for all applications requesting R&D funding, this is our Appendix A and B areas, non-university collaborators in composite can account for no more than 20% of the overall budget. And when I say overall budget, I mean the total funds provided by the government. So that means that you need to make sure that you're not exceeding 20% in composite of all of your national lab and industry collaborators as you fill out your applications and as you allocate budgets. Last thing is funding is for U.S. institutions only. So although we encourage international collaborations for countries that are neither a denied party or a party requiring an export license, U.S. funding cannot go to those international entities in any way, and so under any circumstances. And so just recognize that no budget will be allowed to go to international partners. It's only U.S. institutions. I can go into detail here if people need some specifics on what the definition of a collaborator is, and what those two types of collaborators are and what kind of considerations you have. Ultimately, you as the lead PI, it's at your discretion how you define or how you decide who is a senior and key personnel and who is not. Typically, that means that those collaborators will receive funding. They'll have a major portion of the project, but ultimately, that's up to you and your institution to decide exactly how that works. But ultimately, if somebody is making a defined material contribution on the project, they should be listed as a collaborator. This will help our office understand potential conflicts of interest and manage our review process against those conflicts of interest. So any individual that appears in the project summary, technical narrative, benefits of collaboration, coordination and management plan, budget documents, they should be listed on the application either as a senior and key personnel or other collaborator or personnel. If they're not in that type of a role, they don't need to be listed as a collaborator. And so if you have questions here, once again, extend those to our office, or I can answer questions here as we go. All right, next slide. Cost sharing, encouraged but not required. And then let's go finally with, we've got project administration requirements and then some review criteria review that I want to go over before we finish up the presentation. So first, I mentioned the project and PI transfer. I'm not going to repeat myself there, but this is the exact language that's going to be provided in the FOA, and it's per DOE Financial Assistance Guide, section 4.2.8, if you're interested in reading more about that policy change. Another reminder, pre-award costs for applications that are awarded. If you're in the award negotiation phase, you may charge allowable costs up to 90 days immediately preceding the effective date of the award. You'll want to receive prior approval from a DOE contracting officer to do so if it's greater than 90 days. And from a university standpoint, you just need to recognize that recipients are responsible for pre-award costs if negotiations are unsuccessful. And so that's an at-risk type activity, but it is something that you can do during the award negotiation process. Okay, last but not least, so I realize I've been talking all of your ears off. We're going to go over review process quickly, and then I'll open up for questions. Thank you all. I see all the questions coming in, so I thank you all for your participation. For review criteria, there's a couple of different pieces to go over. Broadly, when you talk about what many people would consider like a program review or a federal program manager review, what we ask our federal program managers to do is provide any mission relevancy reviews. This is just to confirm that the application addresses some part of the NE mission, that it doesn't sit outside. For example, it's not fusion sciences, which is outside of our scope, or medical physics or something like that. And so those NE mission relevance reviews happen to make sure that all the applications correspond with our mission. And then we have a merit review process after that. And our pre-application technical merit review focuses on a broad criteria and a high-level merit review based on originality, creativity, technical merit, and thoroughness of the concept. The full application review is a much more traditional technical review with 3 criterion that are advancing the state of knowledge and addressing gaps in nuclear science and engineering research, technical quality and approach, and team capabilities, risks, and experiences. For reference, the REU aspects of a proposal will be evaluated in criterion 3, the team capabilities, risks, and experiences. On top of all of this, the other aspect that our DOE program managers evaluate is diverse team scoring criteria. And there are additional consideration that's awarded for meaningful participation by minority serving institutions. That could be, for example, meaningful MSI participation could mean an MSI-led application, significant R&D efforts, or significant student involvement by MSI institutions. But those are a set of consideration that are given for exceptional contributions in those spaces. There are a couple of NSUF specific review criteria, a feasibility and readiness review. These are really, you can read through these notes, but these are really during the pre-application phase. Is it feasible? You know, are we putting a billion samples into ATR? Not possible, right? So the whole idea here is the project actually feasible? Is there a way to do it? Is there a facility that could be used to do that type of research? How do shipping and containment work? All of the logistics from a feasibility standpoint. So there's an NSUF technical lead that will be assigned to your application. And the idea here is that guidance will be provided in those spaces to really guide you in what's potentially possible. There shouldn't be any major feasibility issues as the process goes on and as those ideas are honed. Readiness review also takes place, and this is something that takes place at intervals during the review process. And the idea here is, are the samples that need to be tested, irradiated, whatever else the situation is, are the samples available and ready? Are they going to be ready by the time that they need to go into a reactor or something else? There's a huge demand, not only from a user facility standpoint, for those resources, but also from a national standpoint for industry, for other national laboratory programs, for other DOE programs, and for other government sponsors. And so it's really, really critical that we understand readiness. And if you miss your window, for example, to go into ATR, there's no certainty about when that window may open up again. And so that's what the readiness review covers. Let's talk quickly about uninvited pre-applications. As part of our process, the pre-application process is really intended to give you an idea of where the technical strengths and weaknesses of your proposal are. And so we do allow uninvited pre-applications to come back through the process as full applications. Uninvited applications do get another NE mission relevancy review before they move on to a full technical review for full applications. But the idea is the pre-application period is a feedback period to understand the strengths and weaknesses of your proposal. Anybody can submit a full application with one exception to the full application process. That exception is uninvited applications that have NSUF access requirements, the NSUF 1 and NSUF 2 areas. Those pre-applications are not allowed to resubmit as uninvited applications. And that's due to the cost of the feasibility and final cost assessments of those NSUF applications. So like I said, they'll be re-reviewed in full as they go forward. And we get a question almost every year about, is it worth it? And the point I'll make there is we have an open process like this because we have seen that there's a small number of these uninvited applications that are reworked significantly and are successful as part of the overall full application merit review process. So although it's a difficult path to take, there have been successes in the past in those spaces. So with that, I'm about ready to open for questions. From a federal, when I talk about after today, who should you contact? How should you talk with people for interactions with our federal points of contact or technical questions? Please extend those to NEUP@INL.gov. We will facilitate a process where you'll get an answer from a federal program manager. That allows us to understand how federal program managers are responding to all of you and make sure that those answers are provided more broadly to the general public and the general applicant pool, so that the program manager doesn't have to take the same question 400 times from 400 people or something like that. For procurement questions about any procurement related items, Andrew Ford, our DOE contracting officer, is available, and we've provided his email. And then for any general application submittal questions, any general questions about the program or the funding opportunity, you have some phone numbers available there. That's our CINR lead here at the integration office, Pam Rich, and my phone number. You can also submit to our NEUP mailbox, and we'll get those questions to the program manager, the relevant expert in that area. I'm going to leave up a set of due dates here as I open up for questions. So thank you all for listening. I appreciate it. And Josh, let's take questions.
Perfect.
And before we do this, I'm just going to invite John and Jenna, and if Andrew is available to be online to kind of add to the question and answer here.
Okay, awesome. So from the get-go, we have a couple of questions that tie in together. Are there limits on the funding? What would be the minimum and maximum cap? And then to go along with that, how does the time period change if the requested award is under $1 million?
So I'll answer the first one. I mentioned there's no floor, but there's $1 million cap on Appendix A, areas 1 through 11. Area 12, which is the strategic needs R&D, is a $500,000 cap or ceiling, and then up to $3 million for IRPs. And so that's really the breakdown. NSUF cost is defined by NSUF, so that's not something that is really within the control of the applicant. To answer the second question, if I'm remembering it correctly, the question was, if it's under $1 million, how does that affect the period of performance? or the overall number of years, that's at the discretion of the PI. We've seen, you know, $500,000-$600,000 awards that have gone on for 2 years. We've seen a $500,000 award that goes on for 3 years. So it's really, that should really be driven by the scope that you're trying to complete. You know, the idea is up to 3 years of project duration, regardless of the funding amount. That should be at the discretion of the proposing team.
Great, thank you. The next question, is it known how many projects will be funded under each topic area?
That's unknown. So there's a couple of uncertainties there. Like, for example, we don't have our FY 2025 budget at all. So there's some pieces there. What I will say is that there's a commitment from DOE that if it puts out a topic area, if there's quality applications in that topic area, the intention of DOE is to try to provide an award in each topic area. Outside of that, I think there's too much uncertainty to provide any more detail there. Jenna, anything you want to add there?
No, I don't need to add anything, Drew. You're right on that. Sorry, I couldn't unmute for some reason.
Oh, no, you're good. You're good. No problem.
Okay, thanks.
Awesome, great. Next question, for fiscal year 2024, the period of performance was 3 years and 2 months. Is this changing back to 3 years in fiscal year 2025?
It is. So we have simplified that a little bit. Similar to FY 2024, we will be negotiating these projects by August 1st. And the idea is that we'll just have a 3-year project period, and then you'll have an opportunity to request an up to 1 year no cost extension if you feel like there's some delays that need to be accounted for. But yeah, we're going to push it back to 3 years, meaning that we would start on August 1st, and 3 years later on July 31st, that would be the end date for all of the awards for this funding opportunity.
Great. All right, okay, we have a couple of questions here all about REU, so we'll try to knock those out all at the same time. Can I apply for REU only, not as a supplement?
No. REUs can only be applied to as a supplement. So, yep.
Perfect. Next one, can we budget MSI faculty as part of the REU?
So REU funds are intended for undergraduate research experiences only. The MSI faculty type activities would likely come out of the traditional R&D portion of that budget.
Perfect. Stipend only, or can travel be part of REU?
Yeah, so there's some considerations for a summer program that are outside of just a student stipend. So if there's questions about that, I would, of course, the baseline or the space that we have used to kind of inspire our own REU program is NSF's REU supplement program. And so we look at those costs very similar to the way that NSF would. And that means that student support costs may include, food, housing, travel support, those types of things to be able to get to the location as part of that overall stipend.
All right. If a proposal includes an REU supplement, does the 20% limit on how much budget can go to non-university partners include the REU? For example, 20% of 1.1 million or 20% of 1 million?
No, so it's called a supplement for a reason. So it's a supplemental funding after the overall project cost has been taken care of. So yeah, I would say it's 20% off of the R&D budget is when you're looking at national laboratory industry collaborators.
Perfect. All right. I think this is the last one for REU. If an REU is not decided to be funded, will the entire proposal be unfunded?
They're all integrated together, and so there is a stipulation in the funding opportunity that DOE can choose to fund any portion of an application that it sees fit, which means that if we exceed, for example, our 20 REUs, the plan would be then to maybe pull back some of the REU scope for some of the other supplements, but that would need to be done during our kind of our final decision-making process as part of the award. So point is, if the 20 REU supplements are all finished and you've proposed one, you shouldn't worry about that if the project has merit and is going forward for negotiation. Whether it has the RU supplement or not attached to it won't really matter.
Perfect. Thank you. Okay, next one. Between submission of pre-application and invitation for full application, example over the summer, if a PI or a co-PI moves from institution A to institution B, can this person still receive NEUP funding at institution B if selected?
Yeah, so I'll refer back to that new guidance 4.2.8 on financial assistance guide. That would be, we would entertain that type of a situation. Now, there's some rules governing how those types of changes would take place. And so that's why I referenced the 4.2.8 section in the financial assistance guide, because it outlines those rules. But the idea is if both institutions are on board, both educational institutions or institutes of higher education are on board with that type of a move, then that could be entertained by DOE. So,
Still need to get, let
go
me
ahead,
just
John.
say, yeah, you do still need to get our permission and DOE's permission to do that. So you have to let us know. Unfortunately, we've had situations in the past where people did that and didn't let us know, and that's not good. So you have to let us know. We have to get permission in that process. So if you know you're going to be doing that, you need to let us know as soon as possible after the pre-application submission.
Yep. Yeah. Thanks for that reminder, John. Yeah, any changes like that do have to be approved by a DOE contracting officer once that application has started its submission, meaning that that pre-application has been submitted. That starts the approval requirement for us to be able to do that. So I know a lot of PIs that are making moves over the summer may talk with their new institution, their new department head, for example, and arrange something with the new institution support to be able to apply as part of that institution rather than their current institution. So there's a lot of different kind of moving pieces and parts and situational type things that are important considerations for those specific questions. If you have one, extend it to us so that we can help you work through the different options that you might have.
Awesome. Thank you. Okay, when will the new PI move policy become effective?
It's effective immediately.
Perfect.
As the funding opportunity releases, it will be effective immediately.
Okay, now we have some questions about the initial review documents. First one, does it have to be Times New Roman or are other fonts of the same size allowed?
The guidance says Times New Roman 11 font. I'll just say that the purpose and the idea of that requirement is to provide the exact same space for all applicants. And so I'll just say, Times New Roman 11 is the size that that's in the FOA. If it's equivalent, I don't think there's going to be a major issue there. But just recognize that if it's even slightly smaller, it's going to be flagged as non-compliant. So it's just a judgment call, I guess. If it were me, I would just put it in Times New Roman 11 font. That's what it says. So
awesome. Great. Okay, the next question, is it possible to create a print entire proposal option that would generate a single PDF with all the documents?
So the answer, is it possible? It might be. Is it complicated? I know that it is from our software development team. And so, it's a great suggestion. It's something that we're aware of. It's a desired feature. And we continually update that system and we'll feed that back to our software developer. So we'll try our best, I guess, is a really bad answer, but is one that is one. Sometimes it's amazingly complicated to do that in a secure federal system, as silly as that sounds.
Great, thank you. All right, the next one. If any office determines other topic areas are more suitable for a proposal, what will the applicant be expecting? An email from any office, or will it just be a suggestion comment?
It will. So if there is if I'm understanding correctly, if there's a change from one topic area to another, that is going to be an interaction. Somebody from my office will reach out to you. to let you know that that has been a recommendation provided by a program manager, and to see if you have any, if you approve of that, if you have any issues with it, to have a conversation about that. So it's not an immediate thing, or it's not something that's limited. We usually have a conversation about that. And they, in all honesty, as we've broadened these topic areas, those have become few and far between, because the areas are so broad and cross-cutting in nature.
Great, thank you. Do active projects refer to being primary PI or being a co-PI? Does that also count?
Yeah, so in this FOA, we would, it's the lead PI or the principal PI, not the co-PI, that those eligibility restrictions apply to. The 6 and 3 application requirement applies to everybody, right? Every university professor, whether they're a lead or a co-PI or in a collaboration status. But when we're talking about the IRP or the no cost extension, or the active project type restrictions, those apply to the lead PI only.
Great, thank you. Does the no cost extension requirement apply to co-PIs or just the lead PI?
I think I just answered that one. It would only be to the lead PI.
Great. Okay, the next question. The data isn't published for how many uninvited proposals are funded. Is it possible to know that number?
We'd have to check with the contracting officer on what we can provide for data as part of the review process. I will say that it is a small number when you think in the less than 5% range is really in that space. And so we'll, as John said earlier to a question, we'll see what's releasable from a website standpoint on some of that data, and get that out to the broader community. Those are things that are typically in briefings, so like the nuclear engineering department head organization, those small details are. So we'll see what we can release.
Great, thank you. Okay, we've got a few questions about reviewers. So the first one is, how will the NEUP office ensure reviewers are being fair and balanced and not evaluating on criteria that isn't stated? Will reviewers that are found to do this be removed from the reviewer pool?
Yeah, so this is a great question. It's one of the most complex things that we deal with here about making sure that we have a robust peer review process that is that's equitable to all applicants that come into the pool. And so we have a review and evaluation plan that we follow on a very strict basis. The key proponents or components of that are provided in the funding opportunity announcement, which you can read about what that process is. And one thing that I will mention as part of that evaluation is that we do a very extensive review over the course of our review panels to make sure that no individual is solely contributing to tanking or elevating a proposal in a way that puts it in consideration or not in consideration. And so there, not only do we take independent review input and then have full review panels for each and every one of the topic areas, both at the pre-application and the full application stage. We also have a process during that review panel that identifies any outlying evaluations, and we specifically talk about those, do something with those. That could include disregarding reviews, finding additional reviewers, potentially doing other actions in those spaces. But the point being is we, as part of the review process, that is really what my team's role and job is to make sure that the peer reviewers are selected, that we have enough of them to be able to make an evaluation of an overall project, that we consider any bias, any conflicts of interest, and then any input that isn't well aligned, with the overall consensus of the panel or overall consensus of our independent reviewers. So I know that's a long-winded answer, but I have a lot of confidence in the overall way that we manage our peer reviewers. And I can get into some more detail if people are interested in understanding how that works. But it should be known that for our independent reviewers, we get independent experts. For our review panels, we have an independent academic review expert, an independent national laboratory expert, and others that sit on that panel who are technical experts in the area. So I have pretty high confidence in the rigor of that review process, but we'll be happy to answer any questions.
Perfect, thank you. Okay, for IRP3, should the leading university be one of an MSI, or would just including an MSI as a collaborator be eligible?
So for IRP3, the lead institution must be an MSI institution, and 80% of the overall federal budget has to go to an MSI institution. So the idea behind that IRP is that it's really intended to build research capability at minority serving institutions directly, not building those capabilities at a different institution or a national laboratory, and then having the MSI use those capabilities. The idea is to develop them at the MSI themselves.
Okay. All right. Could you provide an example of how a PI would bring in HPC computational model capabilities involving a national laboratory? Can any of the national lab participation be considered as cost sharing?
That's a really good question. I will say that as part of the NSUF, Brendan will talk to this, there is the ability to have Department of Energy HPC resources provided. And so I'll let Brendan and Chris detail that out. So that's just one thing to know, is that that's an available resource. Otherwise, there's really, that's maybe a detailed question that would be good for an email. But I would say that if the national lab or other facility, an industry partner or something, is providing in-kind cost share, that is an option for an application. In-kind cost share is not going to count as part of the 20% of the overall federal budget request, right? That federal budget request is the key point there. Cost share or in-kind cost share would not be considered part of the federal budget request.
If a faculty member has one co-PI award, are they ineligible for submitting more than 2 pre-applications?
So if I'm understanding that correctly, it's a co-PI. So so co-PIs typically don't fall under those eligibility restrictions, right? You've got your 6 applications with no more than 3 as lead in the pre-application phase. A co-PI is not going to be bound by a no-cost extension or by any of those other eligibility restrictions we talked about.
Perfect. If you are a PI on one proposal and co-PI on another proposal, does this reduce your chances of having either of the proposals awarded?
No. Nope. Evaluations for these applications are based on technical merit review. So we visited about what those criteria are. That's what the basis of the decisions are, or the recommendations, I should say.
Awesome. Thank you. Another question, kind of clarifying the no cost extension rules. With the new NCE, does that mean current projects that end this year, 9/30, will you accept no cost extension requests beyond the 4/15 cutoff date listed on the NEUP website?
We will accept no cost extensions with the guidance that I provided today. So get those no cost extensions in as soon as you know you need them, but no less than 90 days before the project end date. So yeah.
Awesome. Thank you. Will any consider the option that the applicant can submit 3 names who should not be reviewers of their proposal to avoid biased comments from competitors or conflicts of interest?
So I will the answer is no to that. We don't take reviewer suggestions from PIs or others. What I will say is if you do feel like there is a critical conflict of interest that has not been declared, that you can declare a conflict of interest to the NEUP office at any point in time through emailing NEUP@INL.gov. That way the team and DOE is aware of potential conflicts of interest. So use that as an avenue if you feel like there's some situation where there's a conflict of interest that hasn't been declared.
Awesome, thank you. Okay, are the FOA dates confirmed or tentative?
The FOA, all of these due dates that we're talking about are anticipated and planned, but understanding that if there's some major delay in the release of the FOA, that may force us to reconsider the overall due dates for some of these activities. The idea is, trying to give all of you enough time to prepare your applications and your pre-applications and full applications while still meeting our overall schedule that Aaron outlined at the beginning of this webinar, which is really trying to get awards announced by March 2025.
Awesome, thank you. We have a couple questions that are close to the same. NSF gives opportunities to oppose reviewers in a case that the PI feels conflict. Can such a mechanism be established? Another question similar, how do we flag received reviews that we believe are unfair and biased?
Yeah, so the first piece that I'll mention there is about the reviewers in case the PI feels conflict. We do not have a formal mechanism to do that in the funding opportunity or review process. And I don't anticipate that one of those would be established. We understand the desire for one of those types of processes, but there's also a variety of considerations that go into that, especially the speed at which we can provide feedback and overall evaluation of awards. What I will say is if you do feel like there is a case like this where you believe that there's something unfair or biased, you can provide that feedback to John Gilligan or myself. We can sometimes, a lot of times, we can talk through what the review process is to help you understand it a little bit more and the steps that are taken to consider any potential bias or equity type concerns. But yeah, that's really the space that we get into is, if you get review comments back that you feel are unfair for whatever reason, you're welcome to reach out to me or to John Gilligan. We can walk you through the review process, try to help you understand what your concerns are and help you understand what our overall review process is to try to prevent any unfair assessments or biased assessments. I will say that a lot of times internally, we view those by how an application is actually evaluated, meaning a score or an evaluation type system. Comments are provided to applicants. So there's often a disconnect in these situations where the evaluation was more positive than the comments, for example. We do internally here check for any outlying review scores. We use a statistical analysis of not only current review scores, but all of our historical review scores over the past 16 years to make a determination about what our standard deviations are on potential problem areas from an evaluation standpoint. So I'm talking about from an evaluation or a scoring standpoint. So like I said, I'm pretty confident in the way that the checks and balances we put in place internally here to make sure that those types of considerations don't positively or negatively affect an application individually, and would be happy to talk about what that process is with anybody if you've had concerns, if you have concerns for the future, or have concerns from the past. Really appreciate you all. As a final reminder, do not hesitate if you have any issues or any uncertainty about what we talked about today, or as the FOA comes out, any uncertainty, please reach out to the NEUP office early and often if you have issues. We have a team here that is dedicated to supporting all of you as you make applications to this funding opportunity. And I would encourage you to use that team instead of making assumptions that might make an application non-compliant or something like that. So thank you all.
Okay, welcome back, everyone. We're going to start off with Phase II Continuation CINR.
Hello and welcome, everyone. I'm going to start presenting for Phase II Continuation CINR funding opportunity announcement. This is our second year. The first year has been exciting, and I'm so glad to start interacting with all you lovely people there. So here is the slide. As Joanne introduced me, she is the program manager leading Phase II Continuation CINR from Office of Nuclear Energy. And I, Megha Dubey, am your contact at Innovative Nuclear Research Integration Office for any inquiries and communications related to Phase II Continuation CINR. And for any contracts and procurement related questions, please contact Mr. Andrew Ford at DOE Idaho Operations Office. Thanks, Tyler. So CC already mentioned this previously. The way to ask this question is the questions will be addressed during the Q&A phase of this presentation, and they can be asked by raising the hand in the tab, Teams tab, and your microphone will be unmuted, and you can lead the questions in the chat as well. The questions that do not get answered during the allotted time will be answered via email and also be posted on the NEUP site. For any specific questions on individual eligibility, we request you to direct those questions directly to us, to NEUP@INL.gov email address, and we will have them answered as soon as possible. Next slide, please. So to start with the fiscal year 2025 Phase II Continuation CINR funding opportunity, objectives, and priorities, Drew has visited in details with the objectives of the funding opportunity in general. So they revolve around NE's mission of supporting the US nation's energy need. And the priorities for this funding opportunity are focused on continuing promising research pathways by soliciting applications that directly complement and extend the research that has previously been awarded through CINR projects by NEUP. These projects, by their nature, are extension of the current CINR projects and are shorter in duration and smaller in scope than their complementary CINR parts. The Phase II Continuation project are required to provide a logical path between the current research scope on an active ongoing CINR projects and the new scope in a way that creates a seamless transition between the two. That's the whole point of the Phase II Continuation. And the Phase II Continuation and original CINR projects are separate funding opportunities and awarded separately from the DOE. Next slide, please. Continuing the priorities, the CINR awarded projects, including the R&D, IRP, and mission supporting strategic needs R&D and IRPs that conclude between January 1st, 2025 and September 30, 2025 are eligible to apply. It might seem a little weird for the duration that it is from January to September, but it is to accommodate all the NCEs for the last 3 years of CINR awards and the years before. The fiscal year 2025 Phase II Continuation awards are anticipated to begin on August 1, and the active CINR project and the Phase II Continuation CINR award can now have a minimal overlap, which will not be typically more than 2 months between August 1st and September 30 of 2025 to accommodate the gap. So the Phase II Continuation CINRs can be applied, proposals can be applied in these major NE funded research programs. They are Fuel Cycle Research and Development Program, Reactor Concept Research Development and Demonstration Program, nuclear energy advanced modeling and simulation programs, nuclear energy enabling technologies cross-cutting technology development program, and interim storage for commercial spent nuclear fuel program. And here are important due dates to keep in mind. They will be available once the FOA is released, but the FOA is due to release hopefully next week if everything goes well and planned. The phase 2 continuation LOIs are due on June 5th. And the full applications will be due on October 2nd of 2024. The overview of this award is they can get funding for up to 2/3 of their original CINR project, which falls typically between 300,000 to 1 million, depending on if it is a R&D or a IRP project. The estimated funding available for this program is approximately 3 million, and we are hoping to have approximately 4 awards funded in this funding opportunity. And the period of performance is shorter, as mentioned before, and it is up to 2 years. The official copy of this FOA will be available on the grants.gov and will also be available on the NEUP site. The applications for this funding opportunity will go through the NEUP site, and that is http://www.neup.gov site. Here are some eligibility and restrictions criteria for phase 2 continuation proposals. So only the universities are, as a lead applicant, are allowed to apply for phase 2 continuation. However, they can have other universities, national laboratories, and industries as their collaborators. And the phase 2 continuation also have the restriction that it can be only requested for an ongoing CINR R&D, IRP, or mission supporting strategic R&D and IRP. The restriction are that only one phase 2 continuation CINR can be requested per active CINR, and applications can only be made from the lead institution where the currently active CINR is taking place. The lead PI on the active CINR award and the phase 2 continuation should be the same, unless, as Drew mentioned in the financial assistance guidance, that we are allowing, if there is a extenuating circumstance where a new PI at the lead institution need to be identified, they need to be pre-approved from DOE. And the eligibility restrictions from CINR FOA do not apply to this funding opportunity. And if you need more details, please reach out to us and we can definitely answer those questions for you. So the application process for phase 2 continuation is, the first stage is called letter of intent stage, in which we request you to provide a project description, which will include but not limited to the following information that I'm mentioning. So it should have a scope of the new CINR extension. It should talk about the current progress of an existing CINR award and anticipated deliverables in the final 12 months of the project. The summary of milestone completions, schedule, and performance of the current award, and a description of the new scope of the proposed phase 2 continuation portion of the project, and a mention of how these two projects would integrate and the importance of direct follow-on on the current research objectives should be mentioned. These letter of intent will be combined with the reports that you have been submitting on the PICS-NE, the midterm report, the annual reports, and they will be evaluated by the programmatic expert along with the project description that is required at the letter of intent stage for making the decisions. And only invited applications from letter of intent stage are eligible to apply for a full applications, which is little different from the CINR, where the uninvited applications were also can also be are also allowed, to apply for the full applications. And the full applications, everything else mirrors the traditional CINR R&D FOA process, the document requirements, except we have requested an additional phase 2 continuation application transition plan to describe how the two projects will integrate, and a mention of risk and mitigation strategies to ensure a smooth transition between the projects. And the full applications will be evaluated by the panel of experts, which include the programmatic experts and multiple technical peer reviewers who will be evaluating the technical merits of the application. Please. So here is the list of full application document which will be required for phase 2 continuation. If you see fifth on the line from the top is the transition plan. That's the only different, and the requirement of the page limits, the font size is provided in the FOA. Please make sure to read those carefully. As Drew mentioned, please stick to those so that it's easier for you and us to make sure that the applications are going forward as intended. The formats of these applications are also provided, and the requirement from the lead institutions or the collaborators are included in this summary for each of these forms. And the next slide is the continuation. These slides will be available for your reference, but you will have the full detailed requirement in the FOA. If you have any questions, please feel free to reach out to me and I can give the description. Next slide. So here is the review criteria that we will be that will be undertaken while evaluating the LOI and the full applications. I'll start with the LOI review criteria. First of all the applications that are submitted under this funding opportunity will be evaluated for the NE's mission relevancy. The next are the technical merit criterias. First of which is, you are aware, is advances the state of knowledge and understanding and addresses the gaps in nuclear science and engineering research. The second is a little bit different. It will be evaluating the past project performance, and that's why it's very important in the LOI stage to mention during the entire duration of CINR, how the deliverables were produced. Those things will be considered, like the timeliness of the deliverables, milestones, research progress, the student development and support, and the research productivity. And the third criteria is the same, applicant team capabilities, risk and experience, where DOE will be evaluating the extent to which the applicant team provides objective evidence that it has the resources and abilities to successfully complete and actually continue the R&D project in technically defensible manner. Next one. And the last criteria is for the program managers. They will be evaluating the diverse team review, and that can help to get an additional bonus point, actually up to 3 points, which may be contributed to the overall score during the merit review process of both LOI and the full applications. This is decided by application, which is led by either led by the minority serving institution or having partners that are minority serving institutions, including HBCUs and TCUs. And the diverse team and partnership are not a requirement, but they are encouraged, and they can help you in improving your project proposal score. The full application review criteria is the same. Again, they all will be evaluated for the NE's mission relevancy, and the technical merit reviews are the same, except for the second one, in which now in the full application stage, the focus will be placed on the technical quality of the proposed R&D project, where integration of the past CINR with the new work scope, merit feasibility, and realism of the proposed methodology and approach of the project will be evaluated. The schedule, including the sequence of project tasks, principal milestones, and times of each task will be considered, and the planned assignment of responsibilities, proposed project efficiency, and the technical expertise available to the applicant in carrying out this project will be considered for the criterion 2. The criterion 3 is similar, where the applicant team capabilities, risk, and experience will be evaluated similar to the LOI stage application. And as I mentioned before, even in the full application stage, the diverse team review will be performed by the program managers, and it depending on the team makeup, there's a possibility to have some bonus points for this. And if you need advice on, or if you have any questions on any technical aspect of this phase 2 continuation CINR FOA, please reach out to us at NEUP@INL.gov, and we encourage you to mention which FOA you are referring to by putting the FOA number and the name. And if you have any procurement related questions, please contact Andrew Ford at the DOE contract office, and his email is provided here as well. And for any general applications submittal questions, please reach out to me and email at NEUP@INL.gov, and that is my phone number provided there. And thank you so much for your attention.
Joanne and Megan, this is John Gilligan again. I can't pull up my FOA in front of me, but I wanted to just make sure the budget's typical limit on this phase 2 is 2/3 of the original project, right? As I recall. Yes. And for IRPs, the $3 million. So that would be a limit of $2 million for IRPs for a 2-year period, as I recall. And for the regular projects, that's 2/3 of $1 million, which would be obviously $666,000. So just want to make sure there is a limit on the budgets here. And I want you to check that slide, Megan. There was one that showed a limit of a total of $1 million, but I think that was for non.
Tyler, can you pull back the awards slide, please?
I want to make sure we don't leave 2/3 of the original CINR on our project between $300,000 and $300,000 for the, is that for the, that's for the original. So it's 2/3 of that.
John, this is Drew. I think the idea behind the slide is just to show more or less the range, understanding that it's going to be 2/3 of whatever project is proposed.
The original,
yeah. But yeah, most of those phase 2 projects sit in that $300,000 to $1 million range. I think is the point of the. Maybe it's not written well, but I think that's the point of the slide.
Yeah, I'm sure it'll come up as a question sooner or later. It'll be in the FOA pretty clear. Thank you.
Thanks for the additional input there, John.
Perfect. All right. Does the LOI for phase 2 get reviewed as a pre-app?
Yes, they will be reviewed, and I mentioned the review criteria. So they will be reviewed for the relevancy to the NE's mission as the first, and then secondly, the technical merits will be evaluated. Tyler, can you go back 3 slides? I think it's shown there that this will be the the LOI stage. So yeah, they will be evaluated. Just the project description will be evaluated for all these 3 criteria, and depending on how the project is proposed and how the performance of the original CINR has been, depending on those criteria, they will be sent either invitation or non-invitation for the invitation for the full applications.
So in other words, the LOI is the same as kind of like the pre-application in this case, and except if you're not invited after submitting the LOI, you cannot submit a full application, unlike the situation with the CINR where you can submit a pre-app. If you're not invited, you can still submit a full. So that's the difference.
Awesome. Thank you both. Thank you, John, for the clarity. The next question, for the project in which the original PI moved to a different institute but is still leading the research effort, how should we submit the continuation?
I will defer for this question to Drew.
This is one that is one of those like exceptional or extenuating circumstances. So please reach out to us if you have a specific situation. We can provide some guidance. Generally, the idea is that lead institution and lead PI are going to match. It's understood that if that's not the case, that we would need to walk through what that situation is with the PI and make sure the DOE is aware of and can approve of that before the LOI application actually comes in.
Perfect. Thank you. All right. The next question, does it count towards the 3 pre-apps a PI can submit the LOI phase of phase 2 continuation?
No, restrictions are that only one LOI can be submitted per active CINR. So that's the only restriction. And there is no overall capping on how many applications you can do in a particular year. I hope that answers your question.
Awesome. Thank you, Meg. I think it did.
Okay.
The next question, is it required to have the same team of collaborators on the phase 2 continuation as the CINR full application?
That's a great question. And the answer is no. You can decide who your collaborators are going to be on your new team. And it will be considered during the team capabilities and risk criterion. So there is no requirement for you to have the same collaborators from the previous CINR award. Is the bottom line.
Okay, welcome everyone. We are going to start off with Distinguished Early Career FOA Overview. We're going to hand it off to the Program Manager, Joanne Hanners. Then after the presentation, we will hold a Q&A.
Hi, good afternoon and welcome. So as she mentioned, I am the Program Manager for the Distinguished Early Career Program with the NE Office of External Innovations. So we'll start off with few highlights, I think. Well, new people join, so we need to make sure that we let you know how to ask a question. But just so you know that all questions will be held to the end, that was what was noted. And please remember that if you have something that's specific to you, your topic, your eligibility, or anything like that, please contact us through the website, through the email, and we will get with you on your specific question. Okay, so your application must have a strong tie to one of the NE focus areas. The intent of the FOA is to provide stable support to faculty with research, innovation, education, and new direction that will drive the next generation of the nuclear energy innovation. So we'll go over a few highlights. We only have you submit a full application. We have good news this year. It's $800,000 for the award size for your duration of 5 years, which is an increase from $625,000 last year. We do expect a budget of $3.2 million and up to 4 awards. Highlights, fingers crossed, we're going to be releasing the FOA the week of May 13th, and your applications will be due August 6th. So eligibility requirements, this is for an untenured assistant professor on a tenure track at a U.S. academic institution with no more than 7 years beyond the date of the doctorate was awarded as of the last day of January 2025. Now you can request an extension if you've had a major life event and had an extended absence. So what you would need to do is have a letter signed by the dean, the research vice president, or an equivalent official, and you would submit that to the NEUP at INL.gov, and we requested it as 30 days, calendar days prior to our due date. Just so you know that the length of your extension that could be granted would be however long you were out on your extended absence. So if you were out for 4 months, then your extension would be for 4 months as well. The last thing I did want to mention on this is you can apply more only 3 times, but we have had several applicants that will apply the first time and they're not awarded the second time, and on our third time they did get an award. So I want to just mention that those comments that you receive, really review those, look at those, and incorporate those into your application documents, because we have had success with applicants resubmitting and getting an award. So the program areas that we have are fuel cycle research and development, interim storage for commercial spent nuclear fuel, AMMT, advanced sensors. So if you want to go into the FOA, there are there's a lot of detail that you can go look at that and get some better feel for what each of those program areas are. So here are the application documents. We wanted to draw your attention to, there's 4 of them that are really important that you take a lot of time and make sure that you really take your time, fill out what we're asking for, and submit so you can have a good quality application. So the first one we're going to talk about is the project narrative. Now this has a 10-page limit, so you have a lot of room to go ahead and do a lot of detail explaining your project. So your references are unlimited after that 10 pages. So you want to be sure that you have a really good section that identifies the integration, research, and educational activities, and a detailed description and justification of what your proposed project is going to be. Your career objective statement, that just outlines what are your interests in your educational priorities and how they align with DOE priorities. And that's a 2-page document limit. The endorsement letter from the academic unit, the academic unit head department, is exactly what it's saying. It's an endorsement telling us what your teaching qualifications are, your research and mentoring, your service qualifications, and also your current and future commitment to nuclear energy research. Now that one has a 2-page limit, and then also there is an optional template that you can use. And we just asked, you might want to look at that. Everyone's really busy, so the dean, they may appreciate having a template to complete rather than trying to write one from scratch, but it's up to you. Your full biographical, I call it your life sketch, because it's going to tell us all about all of your accomplishments that you've done. It's going to provide your education, training, your research, all your publications, your patents, your copyrights. So you want to make sure that you list everything in there that you've done. There also is an optional template that you can use. We understand you probably already have one written, but it is also a good idea to look at that and see if there's any areas that you don't have in your current sketch that would be helpful for the committee to look at. So our review criteria, we've got 3, and they're all weighted the same. And so when you're writing your application documents, I really do think it's a great idea if you look through all of these criterion and read through them, and then make sure that you answer the questions. And then once your application documents are completed, go back and look at the criterion again and say, okay, did I answer all of these questions? So for example, criterion 1 advances the state of knowledge and understanding and addresses gaps in nuclear energy, science, and engineering research areas. So you'll want to look, because we're going to evaluate. The evaluation will consider how important the proposed project is to advance knowledge and understanding within the topic area. So you want to make sure that you answered that. Criterion 2 demonstrates an integrated research, education, and service plan to address broader impacts to society. So go back and look at your documents and say, oh, do I have, is my research focused on the training of the next generation of the nuclear energy professionals, or are you doing outreach with students? Are you doing STEM activities? You want to make sure that you address all of those. And the last one is the qualifications for leadership. So do you have in your documentation all your leadership skills? Do you have all the right education and abilities to lead a program or a project like this of this size? Okay, and lastly, we have the same slide that we've had all the other times, but you may be new. So technical questions, NEUP@INL.gov. Any questions for procurement, you'll contact the contracting officer, and it's Andrew Ford. Any general application questions, you will go to NEUP@INL.gov, or there's a phone number there that's listed. And also, we're all procrastinators, so it's best not to wait till the last minute to try and upload all of your documents, because the system will slow down and you have big documents you're trying to upload, and it does get very stressful. So start early, and we wish you all good luck. So do we have any questions?
Perfect. The first question, would COVID-19 related difficulties count against the 7-year rule?
Can I answer that one?
Yes, please.
It could, if you had a serious illness related to COVID or any other illness for that matter, and you got a medically approved extension of your tenure clock, for instance, by your university, that would potentially be a way of getting an extension, if you will. So, but we'd have to see a letter from, as Joanne mentioned, a dean or vice president or somebody of that equivalent stature, or your department head talking about an extension of your tenure clock for 6 months or a year, or whatever it happened to be, and that might be considered, but you'd have to get us all that information.
And Josh, maybe I can just add one last piece, which Joanne went over, but should be emphasized, is when you're making that request, we are looking at the exact amount of leave that you took. For example, if you had an FMLA type situation for 12 weeks, the idea is not that if you have a situation like that, you'd get a year extension. We're going to be taking a look at whatever the leave of absence was and approving only that time period for the leave of absence. So I just want to be clear about how we evaluate those requests as they come in.
Perfect. Thank you. Okay, the next question is: a staff researcher in the university eligible to apply?
No, unless they're on the tenure track. This is only for, as Joanne's presentation, only people on the tenure track are allowed to apply.
Thank you, John. Okay, the next question is: the NRC faculty grant still not considered as another early career for applicants? Historically, it is excluded since usually the department chair is a PI for the NRC, but last year NRC forced a PI to choose between DECP and NRC since they considered DECP in their own criteria. However, DECP did not.
That's still the same. I can take this one too, Joanne. Last year, Dr. Huff definitively said that ours is not, the NRC faculty grant is not the same as ours. So you can apply, as far as we're concerned, you can get both. NRC, that's up to them as to how they determine what their criteria is. But for us, you can apply for DECP if you're named on that NRC faculty grant.
Perfect. Thank you, John. Okay, the next question: what is the eligibility for the DECP in terms of year of PhD and tenure track start?
So does that first bullet answer your question of the untenured assistant professor on the tenure track, no more than 7 years beyond the date the doctorate was awarded as of the last day of January 2025? And if not, if you have a specific eligibility question, you can email that to us and we will answer directly to you.
Hey, awesome. Thank you, Joanne. The next question, just for confirmation, DECP is not part of the number limit of CINR R&D proposal submissions, correct?
That's correct.
Okay, awesome. Thank you, Joanne. The next question, is it okay for the faculty to move to another campus during the award?
So that's another one that, well, I'll let Drew take it because he's talked about it previously.
I was going to say, if you listen to the CINR funding opportunity announcement overview, it falls under that same DOE financial assistance guide section 4.2.8 section. Ultimately, DOE would consider that, but there's a couple of conditions that would have to be met to make a move, right? So if you're in a situation like that, either during the application process or during award negotiation or when the award is awarded, then you would just need to engage with either the NEUP office during the application period or the DOE contract specialist once awarded to get some guidance and walk through that process.
Okay, a follow-up question on eligibility. What about tenure track start date? In other words, are incoming tenure track faculty eligible to apply?
I can take that one too, Joanne. I would say yes, but that depends on the institution that you're going to or where you're going to accept your tenure track position. Are they going to allow you to apply in that category or not? It's kind of up to them. If you know you're going to get a tenure track offer or going to be in that situation, I think that's okay.
Perfect. Thank you, John. Okay, we've got another question about kind of that 6 cap off of the R&D. So is the data available in terms of number of proposals received, and can a DECP applicant be a participant in R&D pre-proposal or IRP in the same year?
Yes, they can participate.
All right, thank you so much, Joanne. Oh, perfect. Another question just came in. Would a mentoring plan from a senior faculty be something that could be used to fortify the basic qualifications of the PI?
That's kind of a trick question. If there's a senior PI is an actual collaborator, no, or any way, shape, or form involved with the writing of the proposal or wants to be a co-PI, nothing like that. Whether they're a mentor in the department, that's kind of up to the department and how you operate in that situation. But I wouldn't put that in the application. Let's put it that way. I think that would make it a weaker application.
Perfect. Thank you, John. We've got one more question. I think it's a clarifying question from one previously. Is it year of PhD or tenure track position that starts the 7-year period?
7 years starts from the day of the award of your PhD.
Oh, okay. Oh,
yeah.
Thank you,
Sorry
John.
about that.
Thank you for the clarity, John. That's good.
That's come up because there is a difference between our program and the Office of Science early career award. So yeah, no, it's from the point where the doctorate is awarded.
Perfect. They're coming in last minute, fast and furious at you, Joanne. Okay, could you kindly also provide information on number of proposals received?
Joanne, I can jump in on this one. Applications received, review information, those are all things that are considered by DOE to be procurement sensitive. And so they aren't released even after the application process is finished. So not information that we can provide now or in the future.
There is a suggestion from the comments about moving the 7-year time frame from start of tenure, not award of PhD. I don't know if that's a conversation to have with. That'd probably be directed in an email toward John Gilligan, would probably be the best route for that.
Josh, I will say that there's been significant consideration put into the timeline that we have chosen for the early career award, and it's intentional. So yeah, I think John or I would be happy to hear that feedback, or Joanne. We're happy to discuss that here internally. But there have been extensive conversations already about exactly how to target that, and we understand the benefits and disadvantages of the decision that or the guidance that we provided here.
We're going to get started with the NSUF overview.
All right, thank you for the introduction. So I'm going to kickstart this presentation and hand it over to Brendan Heydrich, who's the NSUF director. So as mentioned, I'm Chris Barr. I'm the Federal Program Manager for the Nuclear Science User Facility. The NSUF is a user facility, and we provide access at no cost to the user to specialized nuclear research capabilities at Idaho and 21 different partners. And so this presentation is going to provide a overview of the NSUF program as a whole in terms of what we do and the capabilities that we offer, but then talk to the specific areas of the CINR FOA that we participate in, which is the NSUF-1 and NSUF-2 topic areas. NSUF-1 is a joint topic with the opportunity for university PIs to propose research development and NSUF access, whereas NSUF-2 is a user access only topic area and is open to universities, national labs, and industry PIs. And so with that, I'm going to hand it over to Brendan to provide an overview of the NSUF program and the capabilities that we offer, as well as to provide more details. I'll also mention that NSUF is somewhat unique in terms of the FOA. There's additional requirements such as feasibility and readiness reviews. And so we encourage any potential applicants to reach out early in the process to the NSUF program office. And so I'm sure Brendan will talk about that in more detail. Over to you.
Absolutely. Thank you, Chris. So yes, I'm Brendan Heydrich. I'm the director of the Nuclear Science User Facilities. We joke that we're 10% of the CINR and 50% of the deviations from the normal CINR process. So I'll talk a little bit about the NSUF, how it integrates into the CINR, the topic areas that we have with and without research and development funds, and then go over some of the challenges, pitfalls, special issues that you might have in applying to these. As Chris mentioned, the number one rule is if you have a question, reach out to us. All of our information is on the website. That's there on the first slide, all our contact information. The earlier we can integrate into these discussions, the better off we usually are. So we can get started. Next slide, please. Thank you. So we do represent the Department of Energy Office of Nuclear Energy's sole user facility. The Department of Energy and the National Science Foundation have dozens of user facilities all across the U.S. for a variety of purposes. We are similar with them in that we provide access at no cost to the user based on a competitive proposal process. We are different in that our focus is specifically on irradiation effects on nuclear fuels materials, and then some related subjects that we'll get to. We are also different in that we're a distributed user facility, whereas a typical user facility is based around a single, often very expensive, hard to access capability that is, $1 billion and more in infrastructure costs. As opposed to that, we get access to capabilities across the U.S., even at some other user facilities, but basically their excess time, or we partner with them to get a portion of their time, so that we're able to provide our users on a very specific topic or set of topics a broad variety of capabilities, including test reactors, gamma radiation facilities, characterization labs, and high performance computing. So as I mentioned, our foundation is this open and competitive access. We do considerably less, almost zero directed research as part of our program. Instead, we enable research in a cross-cutting fashion across all of the NE, well, at least many of the NE mission areas. Some of our signature capabilities, like that, are these test reactors, so that we started off as the Advanced Test Reactor National Scientific User Facility back in 2007. We were established part of the Energy Policy Act of 2005, along with the Idaho National Laboratory. So you see that number. Our user access costs can go up to $4 million and up to 7 years in length. So there's already deviations from the standard CINR language. Because these big test reactor radiations can take so long, probably roughly a year from the start of your project to get your project, your experiment designed, engineered, fabricated, find a spot in the reactor, get it in there. As little as maybe a short cycle, or as long as several years in the reactor, 6 months to a year of cooling, and then you can get into your data generation part that is the post-irradiation examination and characterization. So we allow these projects to go the full 7 years. It's allowed under the federal regulations. Now, if that's combined with the R&D funds, then that can provide, or it can create perhaps a challenge for funding graduate students or other participants in there, because that R&D funds, it does not scale to the extra years of the project. So we can help you work that out, as to maybe give you some ideas as to where that would be best applied, but that's up to the applicant or the awardee. So in addition to the largest of the projects, the neutron irradiation PIE, we have a variety of capabilities that can allow you to do what we call PIE only, or characterization only, either using materials that we can provide for you through our library, and I'll show you a little bit about that, or materials that you bring. These are intended to be tests of radioactive or radiated materials, fuels, and sensors and other materials. So we would not provide advanced characterization for an unirradiated material. That would be something that you should undertake before coming to NSUF. In fact, we'll ask about that. There are cases where you could only do neutron irradiation only. If it was like I say, a sensor qualification test or something that can be monitored in situ. We've done a few of those, some notable ones just completed. We also have ion and gamma radiation capabilities, so there's a variety of experiments you could do along with that. Anyone that's familiar with NSUF, or if you come to our website, you'll also see our rapid turnaround experiments. Those are considerably shorter and have different requirements and scopes associated with them. They are not part of the CINR FOA. And if you have questions about that, once again, please contact us and we'll steer you correctly. Next slide, please. Thank you. As both Chris and I mentioned, we have a lot of capabilities. This is just a small summary of those. Signature capabilities for us are, like I said, are these test reactors, the advanced test reactor at Idaho, the treat transient test facility also at Idaho, the high flux isotope reactor at Oak Ridge, the MIT R2 reactor at MIT, and then I think 8 more smaller reactors, some at national laboratories, mostly at universities, that are available. We have this breadth again because you definitely need the test reactors to do a high TRL qualification test, but it is very expensive to get into those, and it does take a long time. And while we provide that access to no charge to the user, it is a constraint on the numbers and types of awards we can do. And it doesn't make sense if you bring in a novel material that has no irradiation history and no strong theoretical basis for estimating its irradiation performance. We would want to start that at either a lower power research reactor or perhaps even at an ion or gamma irradiation facility, if that's appropriate, to start building that. And we have done projects, CINR projects in the past, all of which you can find on our website and then also at the NEUP website, where we've done the first part of a CINR was either a low power university reactor test or an ion beam test. Some down selection was done, and then we used one of the higher power reactors in the second half of the CINR project. So that sort of thing is available. It doesn't have to be sort of once or done in our work. Post-irradiation examination, advanced characterization. We have hot cell facilities, both at Idaho, at Oak Ridge, at Pacific Northwest National Laboratory, even at some universities have some shielded cell capabilities. And we have advanced characterization labs for the highest end work. We've also partnered with other user facilities, national laboratories, and now a university to get characterization beamlines. X-ray beamlines at Brookhaven and SLS2, and at the Advanced Photon Source upgraded accelerator at Argonne. That will be coming online later this fiscal year, early next fiscal year. Neutron beam lines at Los Alamos and now at Pennsylvania State University. Positron beam lines at North Carolina State University. All that can be used to do advanced characterization on materials. And then computational resources. We fund a lot of the high performance computers at Idaho National Laboratory. We're getting a new one online. It's running now. It'll be online for users in June. So we do have a lot of capabilities that also will complicate an application to the NSUF. If you know what you want, we're interested in hearing that. If you don't, you just know the kind of data you need. Once again, reach out to the program office as soon as possible, and we'll help you. That we can help you even before the letter of intent is due. So, like I said, feel free to reach out to us, talk to us, and we'll get you the help. Next slide, please. Thank you. So you can see this is just the map shows you where all of our partner facilities are. We are headquartered at the Idaho National Laboratory. It is the nation's nuclear energy laboratory, so that makes sense. We have access to a lot of the capabilities here. We're also physically located in the Center for Advanced Energy Studies, which is in town in Idaho Falls. One of our microscopy characterization suites is here. And then we have, like I said, partnerships all across the US. Some offer duplicative capabilities. Some of them are unique. So, like I said, you can select facilities that you'd like to go to, or you can reach out to us and we can help you do that. But we want to pair you with the best capabilities to get your work done. Next slide, please. Thank you. So if you go to our website, which is the address is on the front page, or Google will get you there. You can find the capabilities that we have in a number of ways. Will get you to the same spot. This scrolling down a little bit on the website will get you this 3x3 block that gives you a summary of our capabilities at a very high level with some more detail below them. We also have this resources tab on the banner to the left that will get you to a number of our database tools that can help you find materials, collaborators if you need them, the resources, the partner facilities, information on previous work that we've done. Like I said, there's also some public summaries at the NEUP website. We've got a little bit more detail here. And then probably most importantly, contact information for the PIs and their teams, publications, presentations, and otherwise. Next, please. Thank you. So if you scroll all the way down the main page, that will take you to our partner institutions. So as I mentioned, as Chris mentioned, 21 partners, including the Idaho National Laboratory. Contact information at a very high level for the partners is this page. In the upper right, you see that View Partner Facilities button. That will take you to the individual laboratories at each of the partners. There's about 50 of those, and the individual contact information. Once again, you can feel free to reach out to these people directly, or you can reach out to us. We'll get you assigned a technical lead to help with your project. That, of course, is confidential. The technical lead won't share any information that we get as part of your application will not. We'll have that information stay confidential. Okay, next slide, please. Thank you. So we've done work I mentioned in the area of irradiation effects on nuclear fuels and materials, but that becomes very wide as soon as you start looking at it. You can see here we've broken this down into 8 areas, sort of broad areas, and you can see the work that we've done over the last 10 years of CINR. Obviously, the fundamental studies of reactor materials is a big issue. That actually covers everything from very novel materials to basically higher TRL materials. Are all there. We maintain an irradiation-assisted stress corrosion cracking hot cell facility with load cells and cracking rigs out here at Idaho that does essentially very high TRL work, but still very important to the current fleet, as well as a lot of capabilities to test basically brand new first-of-a-kind materials. Sensor development, working with the Advanced Sensors and Instrumentation program, has been a part of our work for many years, and you can see that's a significant portion. Additive advanced manufacturing is work that we've been doing since, well, really, I guess since actually the first year of CINR 2015. We got a project, we did some of the initial irradiation testing on AM materials, and we're continuing on that to this day. Welding and joining and miscellaneous work that falls into us as well. Next slide, please. Thank you. Here's a lovely exploded drawing that lists those areas and then some examples of those as we go broadly. If you have a question, once again, in perhaps how your idea, does it intersect with any of this? Once again, please reach out to us. Well, I won't really give you can't give you an assessment of how good your proposal is. You can at least get your tech lead to help you sort of narrow down the focus to make sure that what you're proposing will be relevant and appropriate for the CINR call. And as well, like I said, you can reach out, look at our website. You can see we've got hundreds of publications referenced back to their individual projects. They can perhaps help you narrow down some of the proposed work that you might be interested in. Next slide, please. Thank you. So I mentioned you're welcome to bring your own specimens, or whether you've developed them or they come from another R&D program. or from industry source. But if you don't have access to that, or I guess really the first thing that you should do is consider looking in our nuclear fuels materials library. And this is a physical repository of thousands of specimens. Some came from our previous irradiation projects. If we were to fund a radiation project for you, we would always put in additional materials, both pre-irradiated archive materials and then going to the neutron irradiation, both as spares, but then also to populate the library for the future. Obviously, during the time of your project, these materials are all exclusive to you, but then afterwards, we'd be able to have these materials to leverage the work that you did and sort of fuel future collaborations. But we also have materials in here from other research projects, other programs, material from commercial reactors, decommissioned harvest material, research reactor tests, in fact, material from all over the world is available through the library, along with the provenance, characterization data, chemical certs, and then links to presentations and so on that came from this. So you should be able to get access to one of these materials and get a fair amount of context and provenance for it. We're always adding new materials, so please reach out to us for this. The information is available on the website, but we also have a full-time person that manages the library that can help you find materials and pick the ones that should be integrated into your proposed project. Okay, next slide, please. Thank you. So we have two topic areas, as Chris mentioned. NSUF 1, if you participated in previous years, this might have been split out into different areas. For these for simplicity, for the 25 CINR, ththese are bundled into one area. So this is the area where it's university only to the lead, and that all the rest of the rules in the CINR that are appropriate to that apply. But it is 7 years long, up to $1 million of R&D funds associated with that. The NSUF access funding, which you don't see as an applicant, will tell you what the number is, but that all goes out to our partners to fund your work there. We do have some specific requirements for this. Because this is intended to be essentially sort of the second phase of a project, we don't do development work under either of the two NSUF topic areas. We intend for that development work to have been done in some other way. That could have been a previous CINR project. It could be developed in industry, other funding. What we want to do is we want to fund the testing of these, at least the somewhat mature device material. If you bring a material to us, well, and the information is in the FOA, we'll want to know, was it pre-characterized? Have you done essentially all of the benchtop testing you can do before it's decided to go into the test reactor? So that really, we're doing an integral test, adding radiation to it. Obviously, that's focusing on the radiation testing portion of it, but the material readiness applies across all of the different projects. We want to pretty much, at least at a high level, you have that material in your hand before we were to execute the project, so that we can execute it and meet the time schedule that we laid out in the project. All of the information, once again, is in there. Please ask us any questions about that and work with your assigned technical lead to make sure that your project is ready and that you've made it clear in your application. Just like any of the other merit review requirements for the requirements for the CINR, we will there will be a review of the readiness based on the material that's in the FOA, and if it's judged to not be ready, then the application probably won't be able to go forward. Okay, next slide, please. Okay, thank you. So the areas that we're looking at in this project, like I said, they are the same as we mentioned before. You can do neutron irradiation and NPIE, characterization beamline work, ion gamma radiation, and you can always access high performance computing capabilities at INL through the project, and it can be added to any project. We're interested in interesting, valuable, and feasible research projects. So if you have questions about what your concept of the project looks like and does that fit, like I said, reach out to us, work with your technical leads to make sure that will happen. But as was mentioned, we do have a non-proprietary user agreement that will be part of the contract between an awarded researcher and the program. So that is supplied in the FOA at the back. You'll need to read that, and you will need to indicate that you accept it. Otherwise, once again, the application won't be able to go forward. Okay, next slide, please. So the areas that we're interested in for the NSUF1, the topic area that provides R&D funds, are fuel and core materials, and once again, so radiation performance, combined effects. So, like I said, really as much work as is feasible to be done ahead of time, so that it doesn't have to be done during this part. So, so we can spend our time, our effort, and yours on doing the irradiation testing part. You can see what's available. There are some fuel types that maybe aren't as relevant as others. That would be the look at our website, look at the Department of Energy Office of Nuclear Energy's website, talk to people to make sure that the materials that you're interested in testing are in fact appropriately relevant and responsive to the call. I mentioned before the advanced manufacturing and materials. We're interested in that, as well as other structural material issues that can be relevant to nuclear energy work, as well as sensors, instrumentations. We've added active components because we've been doing some testing. Right now, we've got a project that was awarded in 2022 in that call, looking at seismic dampers for nuclear power plants. So we're interested in obviously supporting anything in this general area that will help current advanced reactor technology in the U.S. Next slide, please. Thank you. So we'll see our parallel topic area here. Once again, this is a deviation from the typical CINR. This is NSUF access only. Universities, national laboratories, or industry researchers can lead this. There is no R&D fund supported from this, so we will be asking as part of the application where your funding is coming from. And then otherwise, the rest of the requirements apply. So readiness of materials. These projects can be anything, but they are typically even more mature than what we might see in NSUF1, but they don't necessarily have to be. Next slide, please. And thank you. And so for your reference, this is the same as the NSUF topic area, the restrictions and the types of projects we do. Next slide, please. Thank you. And these are the same sort of specific areas of interest for that. One more slide, please. Thank you. I mentioned cautions and requirements. We are different. We add some complexity to the applications for NSUF access. So, like I said, contacting us early with any questions, even if you're just not sure, because there's a lot of potential that a mistake in the application for an NSUF could lead to your application not moving forward. And we really don't want to, we want to have your good application come in. So please read the section on the user agreement. It must be signed, it must be accepted. Readiness requirements are very strict. They go towards our ability to execute the project, so we take them very seriously. And we need that both in terms of you knowing that your materials are ready, but also explaining that to us by answering the questions in the application. We don't have a way to reach out to you to ask those questions outside of the application process. We will also be doing feasibility reviews ourselves and our partners. If you propose work at one of our facilities, that facility will respond to that and tell us whether or not that can be done. And then, of course, we aren't going to duplicate any work, whether it's work that we've done before or work that's actively going on in another program. Next slide, please. And here's the schedule again. This was presented a number of times, and it'll be on the front page of the FOA. These are, for the most part, they are draft dates, but they are non-negotiable. If you have a problem uploading something to the system, you have a problem getting something done, please reach out to us before it's due. Then we can actually do something about it. And then next slide, please. And this is points of contact. That's Dr. Barr's email, mine. We have two irradiation scientists that can help you out. The lead for the library, and then all of our partner contacts are available there. And that's all I have. I'll have to take any questions.
Perfect. So we'll be quick with this one. It might be a more general question for just DOE. Is it okay for the PI from the university to file for a patent or disclosure before the proposal or during the work is in progress?
That is not for me. I am not a lawyer, and we do have a patent rights discussion in the user agreement, but that's somebody else wants to answer that. I'm fine.
Yeah, and Brendan, I'll just say that there is a section in the FOA about invention disclosure and these types of issues. I'm also kind of in the same space that you are. I'd rather refer that to our DOE Idaho contracting specialists who can describe that a little bit better. So I think that's all that we have for this, and we'll get back to you.
Okay, I think we have time for one more. For NSUF2, no research support is provided, but may I know what the support budget showing in the slide is for?
Yeah, sure. I can address that, and Brendan, you can add any additional comment. So the 4 million on the NSUF2 is the user access. So this is not funding in terms of the R&D as was discussed, but this is the cost for the program to execute the user access project. So for example, the cost to do the irradiation, that cost doesn't go to the user at all.
Hey, thank you guys so much. We're going to move on to the infrastructure FOA overview. That's going to go from 3 to 3:30 p.m. and I'm going to hand that over to Andrew Bollinger, who's our program manager.
All right. So good afternoon, everyone. My name's Andrew Bollinger. I'm part of the NEUP team, mainly focused on the infrastructure funding opportunities, along with some of my colleagues. I'm also the federal program manager for University Fuel Services, so some of you guys may recognize me as well. The FOA today will mainly be focused on the scientific infrastructure support, the first one there listed out. We do have the reactor sharing and the infrastructure revitalization FOAs, but I'll be only going over those on a preliminary manner. So from that, if you can go to the next slide. So the highlights here, like I mentioned before, the scientific infrastructure support for CINR, that will be the main focus of this portion of the webinar. I'll be going over some highlights and the schedule, followed up by Brendan will chime in over the NSUF kind of integration component of this. I'll go over specifics for reactor upgrades, which is the two areas of this FOA, as well as the general scientific infrastructure area. And I'll follow that up with contact information. And then finally, again, we'll look at the preliminary aspects of the FY25 infrastructure FOAs for revitalization, infrastructure revitalization, and reactor sharing and outreach. Okay, if you can go to the next slide. So similar to prior years, the funding mechanism is going to be through the Office of NE, and grants will be issued through DOE Idaho. So the funding opportunities is for two U.S. universities. It has two areas: reactor upgrades and general scientific infrastructure. You can find the FOA at grants.gov. You'll submit the applications through NEUP.gov. The schedule at the bottom, we are having the pending FOA release week, which will be next week. Applications for the infrastructure support will be due July 17th, and we are targeting announcements towards March of 2025. Next slide. All right, Brendan, if you don't mind picking this up.
Thank you. So we mentioned, we talked about what the nuclear science user facilities. Because we've been established to offer these capabilities to all the Office of Nuclear Energy researchers, we also participate, at least partially, in this FOA to help both provide a database and discussion on what already exists out there, as well as we have 8 national laboratory partners and 12 university partners that the university partners participate in this, and we're interested in new capabilities that could be considered part of the NSUF. So we ask for people that applying to this FOA to look at the NSUF database, what's in it, and then compare that to what they're asking for. And then if an awardee has a new capability that's interest to NSUF, in the future, we may start a discussion about partnering with NSUF. You're under no obligation to become a partner, but that this type of infrastructure would be of interest to us.
All right. Thank you, Brendan. All right. So the next, this is just kind of a brief slide showing that we're going to start out with the university reactor upgrades portion or area, and then I'll talk about the general scientific infrastructure area, followed up after that. So go to the next slide. So the reactor upgrades funding portion of the funding opportunity is for research reactors where the DOE owns the fuel, and this is expected. You can find some details for the requirements of this in the FOA. So if each university with a reactor is allowed to submit one application per reactor that is operated. So for example, if a university had 3 reactors, they could submit 3 applications. We have a total funding level estimated at around $2.5 million, and we anticipate to make several smaller awards. The anticipated range of award may be no more than about 1.5 million, but we can do up to a maximum of 5 million. The period of performance is typically suggested around 1 year, but we do allow longer periods. For example, if you needed a regulatory approval, you're allowed to build that into your schedule. Okay, go to the next slide, please. So each reactor upgrades application will receive a merit review by the DOE, some peers, NSUF reviewers, and this is similar to many prior years. Please keep a close eye on the review criteria. So 40% will be for safety and security, and that is the potential of the requested equipment or instrumentation that would enhance or modify the research reactor, like increasing quality, safety, security, or efficiency of the operation of the facility. 20% will be to impact. How is that requested equipment or modification will improve the ongoing NE research and training capabilities? Utilization is another 20%. And as a result of it, how much will you get improved usage from adding this equipment or doing this modification? And then finally, execution. How will you do this? Timelines, schedule, costing, budgets, et cetera, and feasibility. Okay, you can go to the next slide. So some focus areas, this is slightly changed from the previous years. There is a still strong focus on safety and security and operations. It's still extremely important, but we are looking to expand upon the impact of nuclear engineering and science, and the resulting improving operations is a consideration. And we will consider, like many years prior, that spare parts and hardware will be highly regarded. Again, the big thing is we want to keep these facilities going. We want to keep them as useful as we can. So go to the next slide, please. So moving on to general scientific infrastructure. This area is allowed to all U.S. universities to apply, but that is limited to 1 application per university. The award size is around $250,000, or sorry, is $250,000, and anything above $250,000 will require a cost match. So, for example, if you had a $300,000 effort, the $25K would be from the DOE, and then the other $25K would have to come from the university in some form. Total available funding for this will be estimated again around $250,000. And like reactor upgrades, to be clear, 1 year period of performance is typical, but longer periods of performance are allowed. Okay, if you want to go to the next slide. So like reactor upgrades, there is a review criteria. The percentages are a little different for GSI. Impact, they're all equal at 25% each of impact, utilization, execution, and educational innovation. So for impact, we're looking to that criteria would be looking at how the requested equipment or modification to a facility will facilitate or improve ongoing research. Utilization, like how much the students or faculty will use that capability. Execution, like previously, budget, schedule, feasibility. And then for educational innovation, how much will be used for educational purposes? How much are we going to be using that to train our future workforce? One thing to note, based on the close integration from NSUF being early in this effort, is that we will be providing up to 3 bonus points for NSUF priority. And with this, the applicants need to show that the proposed infrastructure or addition or expansion is worthwhile for NSUF to have any chance of getting bonus points. Okay, next slide, please. So the focus areas for GSI are very similar as previous years. Software and instrumentation associated with non-nuclear reactors that support nuclear energy R&D. Some examples are including specialized facilities, classrooms, teaching labs, non-reactor nuclear science and engineering research. And we are encouraging requests that support the sharing of equipment across multiple campuses or of universities or colleges and even some national labs. Those are strongly encouraged. Working with consortia, collaborative agreements is definitely a positive for this area in the application. Okay, slide 12, please. So just a reminder, there is the just want to make sure that for equipment and upgrades for GSI do not include items for reactors. You can apply to the reactor upgrades portion of this application. Also, since NSUF has a high performance computing resources at the INL at no cost, we will not entertain any kind of HPC or high performance computing equipment in this FOA. And you can see the NSUF website or the hpc.inl.gov website below. Go next slide, please. As I mentioned previously, cost match is necessary for applications above $250,000. This is a dollar-to-dollar match up to $5 million. So, for example, if someone were to propose a $350,000 total project budget, the university would be responsible for $50,000, and then the DOE share would be another $50,000. So for your total project, it would be $250,000 from the DOE, $50,000 from the university or college, and then another $50,000 from the DOE again. Now, cost sharing is encouraged, but it is not required. It's slightly different than cost matching. And if you have any questions, there'll be the contact for the DOE ID contracting officer at the end of my slides. If you have any questions, you can go to slide 14. Okay, so some pitfalls to avoid. The big thing here is that the request should be discrete and definable. We want to support, maintain, or enhance an institution's capability to teach students at a high quality, especially if they're interested in nuclear energy related studies. We want to build various institutions, research or education capabilities, and we want to be relevant to the DOE and NE's missions. So another pitfall is that to avoid would be to focus on a single goal or capability. Several unrelated items, they may not necessarily meet the goal like a shopping list. You may want to be focused. If you have a series of items, you want that to be a cohesive argument. If they're all kind of disjointed, it may be a little difficult to. It certainly would be a pitfall. And if you are trying to be an NSUF partner, try not to duplicate capabilities that are already existing. And finally, list out any relevant or DOE R&D effort that's ongoing. Okay, next slide, please. So these are the primary contacts. For any technical questions related to this funding opportunity, you're welcome to reach out to Brendan. He may redirect you to an appropriate party at INL. Any procurement related questions that can be submitted to Andrew Ford. And you can also, and as I mentioned before, the application site's at the NEUP.gov website. And if you have any other questions, there'll be there's the website at the very bottom there. All right. So that, if you go to the next slide, that covers the scientific infrastructure support, every year. The next two slides are going to cover reactor sharing and upgrades, and then infrastructure revitalization. Between those two, we will be setting up another webinar in a couple weeks. That's a couple months, excuse me, to address that. They are staggered in release date at this point, and it's just something to note. So I'll start out with reactor sharing and upgrades. Reactor sharing and outreach. We still are developing these FOAs at this time, and we plan to have a webinar, as I mentioned, for reactor sharing. We are targeting a release date mid-August, August 15th. Similar, it'll be, intend to have it similar to last year's funding opportunity. We are encouraging reactor sharing for the 24 universities with research reactors, and especially to work with universities without research reactors, work with different educational levels, K through 12, vocational and community colleges. Outreach to the public is also a big portion of this effort or potential effort, and it's also extremely important that we help advocate for nuclear science and engineering. Some parameters from this FOA are at the bottom there, kind of a reminder from this fiscal year 24 funding opportunity. The intention is 5 awards, $200,000 each, and a period of performance of 2 years. The lead institution in these applications must be one of the 24 universities or colleges with a research reactor. So that narrows down who'd be interested. So go on to slide 17, and I will be rounding this out. The infrastructure revitalization FOA will be later in this year. It'll be released in November in order to stagger the funding opportunities. So like last year, we are looking at a consortia style model that combines infrastructure, research, training, student support, et cetera. This funding also does not support the planning or construction of new university research or power reactors. And then some parameters from last year's FOA, or the fiscal year 24 FOA, are as follows. It was a single $6 million award with a period of performance of 4 years, and 50% of the funds must be used towards a physical infrastructure. And non-university collaborators can have no more than 20% of the overall budget. Cost sharing is encouraged, but not required. So with this, I just want to remind the group that the last slide for reactor sharing and revitalization are preliminary at the moment, so we may not have all the answers at this time for those particular 2 FOAs. Okay, and with that, I'm completed. So I'll open the floor for questions.
Okay, looks like we have one question off the bat. How can DOE support a $5 million project when the total available is $2.5 million?
Andrew, I'm happy to take this one. So the overall estimated budget for this funding opportunity is $5 million. Why it says up to $5 million as a ceiling is it may be very unlikely that all 5 million of those FOA dollars would go to one project, but it's within the realm of possibility if that project had exceptional technical merit and would likely, create a national new national infrastructure type capability. So it's to make sure that if there's some major infrastructure capability that folks are looking at, but feel like they can't go above that $2.5 million, it's really to indicate that, yes, you could go above that $2.5 million. And of course, it would likely need to be something exceptional to eat that much infrastructure budget. But it is within the realm of possibility. So I hope that answers the question. If there's further questions on that, Andrew, I'd be happy to answer them.
Perfect. Thanks, Drew. Next question, when will the results be announced for FY 2024 revitalization program?
I think it's still in the final approval process, the final review process. And so we are targeting this month for that type of an announcement. But that's always the target. There's quite a few review and approval steps that have to happen for any funding opportunity. So I would anticipate it here in the next few weeks. That's when we're targeting.
Perfect. Thanks, Drew.
Okay, welcome back, everyone. We're going to get started with the UNLP overview. So I will hand this off to Program Manager Jenna Payne.
Thanks, Cece. Good afternoon, everyone. I'm Jenna Payne, and I'm with NE's Office of External Innovation. I serve as the Federal Program Manager for the University Nuclear Leadership Program opportunities. I just want to thank everyone really quick for joining us today as we provide you with information on our undergraduate scholarships and graduate fellowships. This program, in my opinion, is one of the most important things that we do. As Dr. Goff mentioned this morning in his welcome remarks, NE has now awarded 833 undergraduate scholarships and 435 graduate fellowships for more than $73 million since FY 2009. This past cycle, we saw an increase in the number of received applications, which is fantastic. And last month, we announced 93 scholarships and 34 fellowships. We're now working on the release of the next round of our requests for applications in August. So similar to years past, I'm asking everyone to keep helping us promote these opportunities so we can continue this positive momentum and attract students to nuclear energy related disciplines. We constantly hear from students that they learned about our opportunities from their professors. So we really rely on your support in getting the word out, and we thank you for it. If you need materials to help you advertise, we can get some literature out to your university, or if you're interested in setting up a webinar for your students and faculty to learn more about our student activities, please reach out to myself, Tyler, Cece, and we'll take care of you. Again, thank you for being with us this afternoon, and I'll pass things over to Tyler.
Cool. All right. Hi, everyone. I'm Tyler Newitt. As Jenna said, I support the UNLP programs and all of our student programs here out of the Innovative Nuclear Research Integration Office alongside Crystal Sosala. We'll also have Andrew Ford on a little later. He's our contracting officer, and he'll talk about the UNLP funding opportunity. But I'm going to go over the student scholarship and fellowship opportunities first. I can get it to change. There we go. So first things first, if any of you are just jumping onto the webinar, as Cece said, we'll have question and answer time at the end of the slides. So you can either type your questions into the chat and we'll get to them that way, or you can use the raise hand function and we will unmute you so you can ask your question. So the UNLP program was established in 2009 through the Omnibus Appropriations Act, so it's quite a long-running program. And it is a joint effort between us here at the DOE alongside the Nuclear Regulatory Commission and the National Nuclear Security Administration. All of those offices offer different programs. So here at NE, we offer scholarships and fellowships. The NRC does faculty development and also offers their own scholarships and fellowships, and the NNSA has a multi-university consortia. So we specifically deal with students who are studying topics related directly to nuclear energy. Those with more of a NRC aligned focus can apply to their scholarships and fellowships. The objective, of course, is to attract the best students to nuclear professions, which we do by offering undergraduate level scholarships as well as graduate level fellowships. And those are available to any student pursuing a nuclear energy related degree. you know, the goals, generally speaking, are just to enhance the research and development capabilities of U.S. universities, and also to help build the next generation of nuclear energy workforce, to establish a pipeline to fill the national demand for trained scientists and engineers, as well as technicians, anyone who's going to be supporting our nuclear energy future. We have here a list of relevant disciplines. I won't go through them all. It's pretty self-explanatory, but of course the disciplines that are not a priority, those are medical physics, nuclear fusion, nuclear forensics, and environmental management. And again, for the most part, these are disciplines that are not a priority to NE, but students may be able to find other scholarship opportunities even within the UNLP umbrella that allow them to pursue those, but not here through DOE-NE. So what do we specifically offer? Through our funding opportunities, we have our scholarship and fellowship requests for applications. That's what I'm going to be talking about. We offer undergraduate and graduate students from 2-year and 4-year institutions of higher education who are pursuing a discipline related to nuclear energy, those scholarships and fellowships. Those opportunities we promote through a mailing list that's on our website, that is NEUP.gov. If you haven't seen it yet, we'll have that posted a little later as well. We also do a lot of outreach at conferences and university visits. I was just out at the ANS student conference talking with students there, so we do a lot of reaching out to talk to students. And as Jenna said, this year we awarded 93 scholarships and 34 fellowships. So somewhere in that range is about what you can expect through our funding level, which is about $6 million. And the next round of RFAs, we're going through the process of putting those together now, and those are expected to release in August. So they won't be with this upcoming wave of CINR releases. They'll be a little bit later on in the summer. We also have the university funding opportunity announcement. This is for universities and colleges to establish their ability to accept student scholarship and fellowship funds through UNLP and manage the award. As I mentioned, Andrew Ford, our contracting officer, is going to be talking about that a little bit later. But that is essentially the way that universities can apply to support their students, and since all the funding is administered through students' universities. So for award amounts, this is for 4-year colleges and universities. We have our scholarship, which is a $10,000 1-year award, which is available to undergraduate students. And we have our fellowship, which is a $169,000 award across 3 years. And that's available for, undergraduate seniors or first-year grad students to apply. We want students to apply when they would be right at the beginning of their graduate studies, so they can take full advantage of the fellowship. We do have some general requirements. You must be a U.S. citizen or legal permanent resident. You must be, for scholarships, you must be beyond your first year in college. You must be enrolled in a UNLP approved college or university. As I mentioned, that's based on the FOA application. It's something where we can work with the university in order to get them enrolled, but because that's how the funding is administered, we can't award students whose university is not approved and is not interested in being approved. As you saw before, it must be a field of study that's related to nuclear energy. There is a GPA requirement, which for the fellowship is a 3.25 undergraduate and a 3.5 graduate GPA. And for the scholarships, it is just a minimum 3.0 GPA. Our trade school and community college scholarship program is in a little bit of a state of flux right now. We're still working on changes that we hope can more directly benefit 2-year students and universities or IHEs, and we're working with 2-year schools to kind of come up with a better solution. So I've put up the award description for last year, which again is the goal is to train nuclear energy related technicians in areas like health, physics, radiation protection, and reactor operations. And that was a 1-year $5,000 award. It may still be, we're just working on what that's going to look like next year. So stay tuned. As I said, these RFAs are releasing in August, so you can get a clearer picture of what that's going to look like around then. And a list of the required documents that your students are going to need. So for the scholarships, it's a career goals essay, 3 letters of reference for the 4-year schools. If the 2-year school program stays similar, it'll be 2 letters of reference, and their unofficial academic transcripts. And then for the fellowships, we ask a little bit more, still the career goals essay. We also ask for a graduate research plan, and for a leadership summary on top of the letters of reference and transcripts. We also do track we do have a required reporting plan for the fellowships, as well as an internship requirement. They must participate in a minimum 10-week internship, which can be at DOE, it can be at a national laboratory, or any facility that is designated and approved by NE on a case-by-case basis. They're also on top of their graduate fellowship stipend. There's an additional $7,000 allowance that goes to offset the costs of travel and housing. And this is something that the students generally work with their advisors to determine what would be an appropriate internship for their graduate study. So, we want the students to not just be doing something to fulfill the internship requirement, but to do something that's going to help them advance their research for their fellowship. And we do ask them to submit a report at the end of that. We also ask the fellows for an annual report at the end of the academic year, as well as a final report at the conclusion of their award. And this is just so we can, see their accomplishments for the year, what their plans are for the upcoming year if they're not concluding, and also a list of presentations, papers, and patents that we can highlight. We also do ask that fellows provide us with updates on their career progress for up to 5 years after their award ends. And this really just helps us, see where our fellowship efforts are going. Starting with this past year, we also offer an exchange program for fellows, which is optional. The fellows don't have to do it, but they can opt into the program. Up to 10 fellows are going to be selected to go on a week-long visit, which is going to tour nuclear-related facilities in the United Kingdom. And there will be additional funding provided for that opportunity. It's not coming out of their fellowship award. So with that, I'm going to turn the time over to Andrew Ford to talk about the funding opportunity announcement associated with the UNLP program.
Okay, perfect. Thanks, Tyler. As Tyler introduced myself, I'm Andrew Ford. I'm the contracting officer or grants officer here out of the DOE Idaho Operations Office. Myself and other colleagues, contracting officers, were the ones with the authority to sign these agreements and grants that are, implemented or provided to the institutions for these scholarships and fellowship awards, as well as all the other FOAs under the NEUP program. So as Tyler indicated, he kind of went into some of the details about what the students have to go through in order to apply to the RFAs. I'm going to discuss briefly about what the university needs to do in order to be on the approved list to administer these awards to the scholars and fellows. It's a cooperative agreement that will be in place at your university. I believe we have 68 of them so far under this new FOA, which was issued back in 2020. And under the old program, I think there's about 87 institutions approved under the old FOA. With this new FOA, I think currently we have 68, and we're always, inviting new institutions to apply under this FOA, as it is open continuously until 2030 for universities that have a relevant program to NE's mission and nuclear related disciplines. Next slide, please. And the FOA number is right at the top of the screen there. DEFOA 0002265 can be found at grants.gov, or a link could also be obtained, or a copy of it could be obtained at the NEUP website. And that, as previously mentioned, they're cooperative agreements under this FOA, and there only needs to be one cooperative agreement per institution. And many of the universities, as I mentioned, are already approved under this program, and those awards that are in place are expected to go for up to 13 years, or we expect the end date of these awards that are in progress right now to be approximately 2033 to administer awards that were selected in 2030. Next slide, please. So, for institutions that may not be on the approved list, you're welcome to submit your application if you have a program that you believe is relevant, and you may not receive funding for your initial award setup. We kind of set up an arbitrary value under these awards of $3 million. However, the value that is actually provided all depends on the number of students, scholarships or fellowships that are selected for that particular round. So you may receive funding on your initial approval, or those funding amounts may be provided incrementally each year through modifications to the cooperative agreement. And that selection of students will be done, as Tyler indicated, through that RFA process, which is done separately from the FOA. Next slide. So it is restricted to U.S. institutions of higher education with 2 4-year and graduate programs of students in science and engineering disciplines related to nuclear energy. Students attending MSIs, TCUs, HBCUs, or institutions in a disadvantaged community are highly encouraged to apply. U.S. IHEs with cooperative programs which share coursework between 2 or more institutions to meet the above requirements are also encouraged to apply. Next slide, please. So what are the responsibilities for the institution under the UNLP program? Of course, you must comply with the terms and conditions of the award. As we've previously mentioned, promote the program to the students so we can try and support more students through scholarships and fellowships. Distribute the funds accordingly to the program guidelines, and we do publish those guidelines in the FOA and the RFAs each year as far as what expenses are allowable under each program. And we expect you to be timely in your reporting requirements, and then return any unused funds at the completion of the award or when directed by DOE. And there are no indirect costs permitted to be charged under these cooperative agreements. All the funding provided through these agreements will be provided directly to the students in accordance with the program guidelines. And the old awards that were in place should all have been concluded and are either closed out or in the closeout process with our closeout specialists here at DOE Idaho. Next slide, please. So the required documents are pretty abbreviated compared to other R&D applications or whatnot. It will be, a basic 424 form. We need to understand what the programs are at your university and the faculty supporting those programs for us to make an assessment to see if it can be an approved program under the UNLP program. Of course, the PICV, disclosure of lobbying, certs and assurances, etc. Next slide. And once again, here's my contact information if you have any questions, as well as Tyler's and Jenna's. Next slide. With that, we'll turn it over for any questions and invite Jenna and Tyler back on to assist with any questions that may be out there.
We do have one question that just came in. What is required in the application?
So I can answer for the RFAs for the students. It's these required documents. We don't really ask for much else other than general contact information when they go through the application process. So for the RFAs, listed required documents are what you're going to want. And I believe the same is true for the FOA. So if a university is applying, it's these listed required documents, and not much else beyond that.
Awesome. Thank you, Tyler. Follow up to that question. What if an institution does not have a formal nuclear engineering department or program, but faculty are actively engaged in nuclear energy work?
The short answer is yes, you can still apply and be awarded. Jenna, I don't know if you have more details on that.
I don't. I wondered if John might have some input there. I mean, I would focus on the faculty who are involved in nuclear research and make sure you describe that research well, because we just need to be able to verify that you have an applicable program for us to support students should they be awarded. But John, if you have something to add there, please go ahead. But otherwise, as Tyler said, the short answer is yes, you could still apply.
Yeah, that's exactly right, Jenna. If you look at the number of universities that are approved, probably less than half have a nuclear engineering program, but they all have faculty that are doing active curricula or research related to nuclear energy, and the commitment to have advising in that area, et cetera. That's the real crux of the matter. So it doesn't have to be nuclear engineering. It could be material science. It could be mechanical. It could be chemical. It could be anything, as long as it's relevant to nuclear energy and students are getting orientation, good advice, access to curricula, courses related to nuclear energy and the area that you have an interest. That's the important thing.
Awesome. Thank you, John. It looks like we have a hand raised. VJ, I have, yeah, you can unmute and go ahead and ask your question.
Actually, my question was just got answered. You don't need to have a nuclear energy engineering program or a department necessarily to qualify, right?
Yep, that's correct. Yep, and I put the relevant disciplines back up on the screen. You know, it's again, it's not an exhaustive list, but just sort of the general idea of what we're looking for. This was in the student section, but it applies to the universities as well. You know, certainly if you've got a mechanical engineering department where they're doing nuclear energy relevant research, then absolutely you could apply and have your students apply.
Is there a deadline for this, or you can do it anytime?
So to get the universities approved, it is, as Andrew said, it's a rolling application essentially. So the FOA will remain open continuously until 2030. Generally speaking, universities submit applications if they have a student that they know has applied, so that, you know, that can coincide with the potential students award. But there's certainly nothing stopping you from applying at any time, and we can process that application and you can start advertising to your students.
Tyler, I'd like to add really quick that even if a student, if the university isn't on the approved list, to, you know, still encourage your students to apply. Yeah. We'll work with the university to get you on the list to get an application, and we'll help in any way we can. And if we see a student who does apply and their university isn't approved, we'll reach out directly to the university to start that process as well. So we're looking out for you. We'll take care of you.
No, we do a lot of work on nuclear materials and manufacturing area. We also have a lot of capability in ion irradiation and microscopy and so on. How long does once you apply, how long does it take to know that you've been approved?
Yeah, I don't have a whole lot of other further details. It just depends on how many submitted under that cycle and how long the review process takes in order to evaluate each application. And then I just kind of wanted to reiterate, so the RFAs are typically released annually, approximately in August of each year, with the January due date for students. Is kind of the typical cycle that the students need to be aware of if they want to apply through those RFAs.
And how detailed is the proposal or documents that are needed in the application? Is it a full-blown description about the program, or is it just a couple of pages? Or
We've seen various levels of commitment and application, I would say from a few pages to 10 or more, but it depends what you really commit and what the heart of the matter and what you can show from faculty. You could always refer in links or anything like that to other outside materials, for instance, to keep the application itself short. So it doesn't have to be a 50-page application. It could be a lot less than that.
Yeah, and we typically have a 2-page limitation per discipline in your submission under the program description. Is it typically limited to 2 pages per discipline?
Okay, welcome back. We will get started with the Innovations in Nuclear Energy R&D Student Competition overview. There will be a Q&A held after the presentation, and any questions that are not answered will be posted on NEUP.gov. I'm going to hand this over to Jeremy Gurman to introduce this overview. He is the program manager for this.
Good afternoon. My name is Jeremy Gurman. I'm the program manager for the Innovations program. I know today's been a long day, and I appreciate everybody's patience and taking the time out of your day to listen to these programs. This is the 3rd year that Innovations have been under our team, and we're very excited about next year's program. And I will now be introducing Tyler to go through our presentation. Thank you.
All right. Thanks, Jeremy. As I mentioned, I'm Tyler Newitt. I helped support all of our student opportunities here in the integration office, and I have been supporting the Innovations student competition since we adopted it a couple of years ago, as Jeremy mentioned. Once again, if any of you have just joined and you need to ask questions during the presentation, feel free to either pop them in the chat or click the raise hand button, and we will get to your questions after the presentation. Some quick deadlines. I do want to emphasize that we are still working on the RFA for this year, which we're anticipating an October release. There are most of the stuff I'm going to go over today is subject to change. Don't know how much of it is actually going to change, but we are anticipating a few minor changes for next year, but we won't know those for sure until the RFA is released. So as I said, October, you can look for the release of the RFA, and then applications will likely be due in November, with awards announced in March of next year. So what is the student competition? The Innovations Student Competition is a program that's designed to recognize and award published graduate and undergraduate students for innovative nuclear energy research. The goal is to promote these students' excellent work that's already been published in journals or conference proceedings. And we want to demonstrate the commitment of the Office of Nuclear Energy to higher education in nuclear disciplines relevant to the NE mission. So if you think back to our scholarships and fellowships, the same commitment, same goals align there. And we also want to support communication among students and the U.S. Department of Energy representatives. So it's another opportunity for students to interact with our NE program managers. So the program is composed of 5 competitions. a student who enters, with the exception of some undergraduate students who are not lead authors, any student that enters is eligible for all of these awards. And the awards are selected based on a ranked order on the value of the award. So we have our Open Competition Award of Excellence, which is open to all students, as I mentioned. That is our top tier award, as well as our competition for graduate students attending a minority serving institution or belonging to a disadvantaged community. Then we have our Open Competition Special Recognition Awards, and our competitions for undergraduate students fall below that. And as I said, students who enter are automatically considered for any of the awards that they're eligible for. So just reiterating a lot of the same stuff here, each publication is evaluated for all of the competitions that it is eligible for. And applicants will be considered in all of those categories, but are only eligible to win one award per year. Students can also submit more than one publication if they have multiple publications that were published within the designated time frame, but they can only receive one award per year. The awards vary according to the award level. Some of the awards do come with travel opportunities, typically to the American Nuclear Society winter meeting. We had last year, the FY23 award recipients present there last year. It was a great time. All of the students, though, do have the opportunity to present their work if they so choose. We've been operating a webinar in association with ANS, which allows the students who don't get the opportunity to travel to a meeting to still present their work to the broader community. So we've really enjoyed doing that for our FY23 awardees, and we're going to start giving those opportunities to the FY24 awardees here soon. Students are also provided an honorarium as part of their award package. And yeah. So we have, at least as of last year, 6 topic areas. The topic areas generally are related to the Open Competition Award of Excellence. So assuming we have enough quality applications in each area, we will award, we intend to award one award of excellence in each topic area. Those topic areas are reactor development and plant optimization, flexible energy systems, fuel cycle technologies, spent fuel disposition, nuclear engineering, and energy policy and social sciences. So again, those go to the award of excellence. All of our other awards are at-large awards. So students who submit into any of these topic areas are eligible for those awards if they qualify. The relevant discipline slide looks very familiar if you were just watching our scholarship and fellowship presentation. Again, the key thing here is the disciplines that are not a priority. So medical physics, nuclear fusion, nuclear forensics, and environmental management, not priorities of NE, and so won't be considered for award. Here we've just got a breakdown of the competitions and their award values. So the Award of Excellence, as we mentioned, gets a $3,500 honorarium. Travel and conference opportunities may accompany the award. We generally intend for the Award of Excellence recipients to present at the winter meeting, the ANS winter meeting, if they are able. The graduate student competition, the graduate competition for students attending a minority serving institution or belonging to a disadvantaged community is up to 5 award packages, also a $3,500 honorarium, and they also get the opportunity to present at Winter ANS if they are able. And as the title indicates, this is open to students who are attending a minority serving institution or belonging to an underserved community. The Special Recognition Awards are $2,500 honoraria award packages. These are for students who submit to any topic area, as I mentioned. And generally, this is the start of where we see students who are presenting at our ANS webinars. We have our undergraduate competition for students attending an MSI or belonging to an underserved community, which is a $1,500 honorarium. And the same applies to the undergraduate competition, the $1,500 honorarium and the opportunity to present at our ANS webinars. The travel and conference opportunities are subject to change, but generally speaking, the Award of Excellence and MSI graduate winners have the chance to go to the ANS winner meeting if they're able. Now for eligibility restrictions, applicants must be the first author or principal student author of their publication. As I mentioned before, there is an exception. If the student is an undergraduate, they can be a secondary author, but they will only be considered for the undergraduate award. Applicants must be undergraduate or graduate students, and that is considered from when the publication was submitted for publication. So students who have gone on to do graduate studies, but who submitted for publication when they were an undergraduate are eligible for the undergraduate award, must be studying a relevant discipline. The online application form is at our NEUP.gov website, as most of our applications are. And the other key criteria is the applicant must be a student at the time that the application is submitted, which this year will be November 2024. And we do also require that the applicants be part of an ongoing research program or a research program that was completed in the previous 24 months. A few more eligibility criteria here. Students, as we mentioned, can only be awarded one award each year. And undergraduate awardees, and this actually goes for all awardees, are eligible to compete in any category in future years. There are no longer any restrictions for students who were previously awarded who want to apply again, except that they must apply with a different publication than was awarded previously. And if you were awarded previously, we do ask you to submit an explanation for why your publication was different from the awarded one. Again, same as scholarships and fellowships, the applicants must be US citizens or legal permanent residents. The review and selection process goes to a panel of nuclear energy experts. And this is the process I've described already, but they're initially evaluated for the Award of Excellence, and then they follow on to all of the eligible competitions that they may be eligible for. And this is our current, as of last year, evaluation criteria. The students are judged on their publications innovation, their communication skills, their role in the research, as well as the quality of the journal or conference. Just some notes of award conditions, including what the award package consists of, which is an official award letter, an award certificate, the honorarium, and the travel support if they are students who are going to travel to a conference to present. We also put the awardee's picture and publication on our NEUP.gov website. If a student is selected for award, we will notify them as soon as possible to get registered and submitted for the ANS winter meeting. And that concludes it. Any questions?
Yes, there is one question from the chat.
Okay.
If a student's research is not directly related to one of those 6 categories, can they still apply? For example, a student's research is about nuclear-fueled power cycles.
I believe the answer is yes. We would just ask you to or ask the student to pick the topic area that is most closely related to their publication. Jeremy, I don't know if you have any additional considerations there, but I would say, you know, the key is to pick the closest relevant topic area.
That's the same way I would answer it. Just pick the area that's the closest, and then it would be evaluated.
Awesome. Thank you both. The next question, where can we find the definition of an underserved community?
The definition is relatively flexible, and so there are some resources in the DOE space where you can read a little bit more about the energy equity and energy justice type initiatives that are happening. They have some descriptions in those spaces of this terminology. What I would say is that a student in this application process has the opportunity to declare their underserved community status and describe that. And that assists DOE in applying that situation to the definitions that I mentioned previously. The DOE, DOE energy equity, energy justice leadership provides.
Hey, thanks everyone. Thanks, Tyler. I'm gonna hand it off to Drew for some closing comments, and then we can conclude the webinar.
All right, thanks, Cece. I want to thank everybody for coming out today. Appreciate all of your time. I hope that you learned something new, that you got your some questions answered, and we're looking forward to seeing lots of applications this year. Excited for a new cycle. A couple of reminders as we head off. These slides that were presented today, the recordings of the question and answer and a transcript of that question and answer will be available in the coming weeks as we process all of that information and get it out on NEUP.gov's website. When we do have that information available, we will send out a notice to the NEUP mailing list, along with putting an announcement on the website with those resources. Second reminder is that we will be having a follow-on event to this to talk more about the technical topic area scopes. As mentioned, that will be May 28th through the 30th, and we will be in the next week or so providing some registration information on those sessions so that you all can have an opportunity to interact with our program managers that are associated with each of those topic areas. Last but not least, I do want to remind everybody that if you have questions after these sessions or questions as the funding opportunity comes out, I mentioned this earlier in the day, but do not hesitate to reach out to NEUP@INL.gov. That is a common email address that we can get your questions to the right individuals and get you an answer back as you develop your applications. And with that, we'd like to thank you all for your time. We'd like to thank the presenters and the team that you can't see, but that's behind the camera here, Cece Bell and Josh Peterson, who have not only emceed today, but have put an enormous amount of effort to make sure that this webinar went off without a hitch. So I want to just thank everybody here. Thank you all for attending, and I'm sure we'll be in touch soon. Take care.